Hello JEE warriors, welcome Bharat, hello Kisant, welcome Suraj, welcome Sutruja, hello, good morning everyone. Welcome to the second attempt preparation of the refocus series where we are targeting 99 percentile for all the students who missed out on the first opportunity in January. There is still some time, there is still something which you can do which will improve your scores massively via this series, via the content, via all the lectures that we have done even previously and all the resources that we are giving. Today, again, I'm taking a very high weightage, very important topic for all of you, right? And that is sound, string waves, light and electromagnetic waves. The common thing about all of them is that there are many concepts which are common in all of them, and it is better you study all these chapters together, like the speed of the wave formula, energy of the wave formula, or interference concept or the wave equation. Few things are there little bit different, like beats or maybe Young's double slit experiment, or maybe even standing waves, which might be there in one is not there in the other. So those also will be doing it in this particular class, and also polarization and diffraction is also there. So all the concepts, whatever possible, we are going to complete it in today's lecture, and this is a part of the 2-week challenge. Almost the first week is coming towards the end, and if you have been with me and the channel and the series, very good, keep it up. Audible and visible Gautam Raj, thank you so much. Hello Bharat, welcome aboard. Yes, welcome aboard. Hello Alikya, hello Jaswant. My voice and the video is not synced, is it? I'm not so sure. It might take some time. Sometimes there might be a lag. And if you have not yet liked the video, smash the like button. I need to keep requesting you again and again. It should be a habit. If you are in the class, if you are attending any YouTube class, first thing, go smash the like button, because you have to show your support, your love. It is like a Guru Dakshina which you need to give every time you visit any YouTube lecture. Make sure you do that. And let me also tell you, if you have your friends, your colleagues, your batchmates, your cousins, anyone who is looking to prepare for JEE, NEET or any such competitive examination, we are in your city most likely, because there are many centers right now of Vedantu which are offline centers. We call it the Vedantu learning centers, and not just for your younger ones but also for you, for your advanced and the final days of preparation. You can visit the centers. There are workshops which are happening right now as we speak. You can call upon this number for more inquiries, but also there is a link in the description box. You can see all the cities that we have been spreading across, right from south to north of the country, right? So there are some batches which have actually filled up. Few seats are left in few other batches, but there are many courses where we are looking to ensure that we get some really amazing students who we can actually nurture, change their lives in the next 1-2 years. So if you have your friends, if you have your colleagues, if you have your batchmates, please let them know. The link is also there in the description box. You can also call on this particular number for registering yourself at one of these Vedantu learning centers, because these are smart classrooms which have some amazing features like clickers, smart boards. Video lectures are getting recorded as the teachers talk, so no worries of missing a class. You can always watch the replay. Even at an offline center, the teacher is present, doubt counters and so much more, right? So experience yourself or let others also know about it. They will definitely be very thankful to all of you. So let's start with the classification of waves. My voice is forward, and then just check if it is fine now. Yes, just check if it is fine now. Yep, I hope it is fine. Yeah, Bharat, right hand thumb rule of do one thing, Bharat, just send me a message on our Telegram which is there, right? I will probably send a voice note or a video message, or if I can write it and explain it, I will do that. Okay, Captain Shreyas, the Telegram channel, just post this particular message on the Telegram channel. I'll definitely help you out. Okay, fine. Video and audio still not in sync. Why is this so? What is the issue? Okay, Suraj, don't worry, Bacha, because there will be special backlog and bridge courses which will be coming next week for 11th special students. But this lecture is going to focus on both 11th and 12th standard topics because this is for mainly JEE 2024. Yeah, good morning everyone. I'll just keep starting the lecture right now because or else we'll waste time. Even if the video is not little bit synced, I think it is okay as long as you are able to understand the concepts. Okay, no time to waste. Let's continue, guys. I hope it is still fine. It is still fine, not in so much of sync. Not sure why this is happening though. Okay, anyways, we'll do one thing. We'll just continue as of now. We'll not stop the lecture. Okay, so see, my dear students, your waves are nothing but methods of energy transporting without the particles themselves traveling from one place to another. So when the sun has massive nuclear explosions, that energy reaches us in the form of waves, which we call the light waves. Nothing actually travels, it's the energy which travels, that's all. There is no such particle which travels, it's just the energy which travels. Yeah. If you talk about sound, also when I talk, no air particle which moves and comes into your ear. When I talk, the sound which travels is not because the air molecules come inside your ear. It's because the molecules of air are getting disturbed slowly and the energy which gets transported from one place to another. That is the meaning of a wave. The particles might help in the energy propagation, but the particles do not go from the source to the destination. And you classify waves in multiple ways. One is whether there is a medium needed or not. Like for light, you don't need any medium. Even without the medium, the light energy will come. So it is a non-mechanical wave. But for a wave like sound, you need air, or else you cannot, hear or talk. There is no point in that. The energy won't be transmitted. So sound will become a mechanical wave. Okay, so you have a mechanical wave which needs medium, like the ocean waves, right? Or the ripples of water, or the wave on a string. These are mechanical waves. Non-mechanical waves, electromagnetic waves, light waves, they are non-mechanical because they don't need medium. Then you have progressive and stationary waves. We will be talking about stationary waves in a bit, but the meaning of progressive is the energy is going from one place to the other. It is progressing, like you progress in life from here to here to here, first standard to second to third to fourth. That is progressive. It goes in one particular way. Stationary means the energy is not going from here to here, nor from there to here. It is being trapped. It has been, confined in a certain region. So that is why it is said to be stationary. It is not flowing in either of the directions, or the net flow has been made zero. Another is via dimension, whether it is 1D, 2D or 3D. 1D means like a wave on a string, it is going in 1D. 2D means ripples of water, it is going across the surface of the liquid. So it is flowing in all the two-dimensional directions. 3D means when I'm talking, the sound is going up, front, back, reverse, everywhere. So that is three-dimensional wave. Then you also have how the particles move with respect to how the energy is flowing. Video is lagging, not in proper sync. One second, guys. Most of the people are also saying that, sir, it is manageable. Yeah, wave optics is also included in today's class. Like I said, wave optics, sound waves, waves on a string, electromagnetic waves. 4 chapters in one lecture. All of them are relatable. Let me know if it is fine. Let me know if it is fine. Give me a thumbs up. Or if it is not fine, tell that, no sir, it is not at all fine. Now it is okay. Now it is fine. Now it is synced. Perfect. Now it's fine. I don't know. I'm not doing anything. I just restarted my system. That's all. I don't know what just happened. I just closed my software and turned it on again. That's what I was doing even before this, but it didn't work before. Now it worked. So one of the most important principles in engineering they say is that when things don't work, just restart it. Okay, something is not working. Okay, you just turn it off and turn it on. And your computer hangs, what you do? You try to fiddle around a little bit, it doesn't work. Turn it off, turn it on, it works. How that happens? Don't know. Same way, if you stop functioning, your brain stops functioning, what you should do is take a small break and then come back. You will see that again you will be refreshed. You think that you have given up, take a small break, 5 minutes. Don't take a long break that the JEE Mains exam only gets over. So come back within very small amount of time and then restart your preparation. All right, great. Last one is the vibration of the particle, which is basically how the particles move with respect to how the energy flows. So let's say when I'm talking, the sound energy is going from here to here. Sound energy is going from here to here. The particles of sound go back and forth. The particles of sound go back and forth as the sound travels. So the direction is here and the motion of the particles is along the direction of the motion, that is longitudinal. But for ripples of water on the water or sea waves or the wave on a string, the particles move up and down and the wave travels left or right. So they are perpendicular. Perpendicular means transverse. So transverse waves are those waves where the particles or the oscillations are perpendicular to the direction of the wave travel. Even light is a transverse wave because you will see light or electromagnetic waves have fluctuations of electric field which are perpendicular to the direction of the light in which it travels. Is that okay? Yeah. Example of a stationary wave. Well, when you blow a trumpet or when you are playing a flute or you take a drum or a column and you hit it somewhere, you will see the sound will go in, will get reflected back, and then you have two sound waves traveling in the opposite directions. That produces a stationary wave. So most of the musical instruments are based on the principle of stationary waves, where you will see two waves are traveling in opposite directions, mostly by reflection, and you will see that that creates a trapped amount of energy right inside that instrument, and that produces stationary waves. And in certain conditions you will see that the stationary waves resonate, creating very large amplitudes, and that's where you get large amount of sound, or the instrument produces good quality sound. So that happens at resonance. Resonance means it is in sync. Like sometime back the video and the audio was not in sync and you got disturbed. But when everything is in sync, everything works in helping each other, then it is said to resonate and you will get large amounts of energy, large amounts of amplitude, which then translates into good quality of music. Is that clear, my dear warriors? Right. Cool. Moving ahead. There are few parameters of a wave which you must definitely know. Like standard things, guys. The wave goes up and down. Let's say the up part is the crest, down part is the trough. The distance from one point to another identical point ahead, is called as the wavelength. Crest to crest, trough to trough, this point to this point, or this point to this point. That is basically called wavelength. Frequency is how quickly you are going up and down. That means how many oscillations are being produced per second. If there are 10 oscillations per second, the frequency is 10 Hertz. If there are 50,000 oscillations in 1 second, the frequency is 50,000 Hertz. That is what it is. Speed is how quickly the wave is going from one side to the other. So sound travels at roughly 340 meters per second. In 1 second it goes 340 meters. If you talk about light, it goes 3 lakh kilometers in 1 second. So every speed will be different for different kinds of wave. Amplitude is the extent till which it goes up or down. Remember, amplitude is not from here to here. Amplitude is only either this or this. So from the equilibrium, from the average or from the mean, how much is your maximum deflection? That is basically your amplitude, right? So then you have the term phase. Phase means situation. Like what is the state of the wave? Has the crest just come out? Has the trough just come out? Is it just compressing? Is it just rarefying? Is it still in equilibrium? that is the situation. So situation is nothing but the phase. Then you have angular frequency, which is related to this frequency as well. So wavelength was lambda, right? Frequency was f, which is 1 by time period. You have wave speed, which is given by frequency into wavelength. Amplitude is a. Phase is given by omega t plus phi. I will talk about what is omega. Omega is angular frequency. Angular frequency is 2 pi into f. Remember this formula, 2 pi into f, or you can also write it as 2 pi by time period. 2 pi by time period. Time period is the time taken for one complete oscillation. You also have angular wave number. The symbol for that is k, which is given by 2 pi divided by lambda. 2 pi divided by lambda is nothing but your k value. So omega is right over here. Omega into t is like your displacement. Speed into time is your displacement. This is like your initial angle. So some angle which is there before plus the displacement will give you the total displacement which has occurred. Try to relate it with circular motion. It will look very simple. Initial displacement plus, or initial position plus the displacement will give you the total displacement. That is what the phase means. Phase is always expressed in angular terms, because you know that rotating quantities can be converted into oscillating quantities, and this is some concept which you have learnt in the shadow or the projection of it. If you take the shadow or the projection of it, you will see the shadow will oscillate, whereas the original particle will circulate. It will go in a uniform circular motion, and the shadow or the projection or the component will go in a simple harmonic wave-like motion. So that is why you use angular quantities here. What is phi called as? It is usually called as the phase constant. It is usually called as the phase constant, or sometimes also called as the initial phase angle. It is also called as the initial phase angle. It is also called as the initial phase angle. You should also know about the units of each of these quantities. Wavelength is obviously in meters. Frequency is obviously in hertz or per second. Wave speed is in usually meters per second. Amplitude is in meters. Phase, initial phase, etc. is in radians. Angular frequency, you can see radians is there, second is there below, so it will be radians per second. And angular wave number, you can see radians is there on the top and meters is there below, so radians per meter. These are the standard quantities which you must know. Is that right? Is phase relative? Yes, it depends on what you have chosen as the reference. Like usually we take our right hand side line x-axis as the 0 reference, and then you take usually the anti-clockwise as positive. So accordingly angle over here is 0, 90, 180, 270, 360. 0, pi by 2, pi, 3 pi by 2, 2 pi. But somebody takes this as 0, then for them the phase will be slightly different because they have chosen a different origin, right? So that is something which is again relative to what is your reference axis. Remember that. Okay, cool. So what happens is whenever you have to compare waves, make sure that the references are same. You are comparing it with respect to the same reference. For example, you are using a sine equation. Make sure the other equation is also in sine. If it is a cosine equation, make sure the other equation is also in cosine, because you can compare cos with cos, sine with sine. Otherwise, it will be difficult. You have to convert from sine to cos or cos to sine using trigonometric formulas. Now, every wave has a wave equation. Every wave has a wave equation, meaning how the particle is, where the particle is, what is it doing, when is it there, where is it at this particular location, etc. So when we have nothing on the string or nothing on the surface or nothing in the medium, then I can say there is no displacement, there is no motion. So let's say this is our x-axis and all the particles right now are at rest. They are not moving basically. So they are not basically moving. This is when there is no wave which is there. There is no wave which is there. I can say they are all at equilibrium. They are all at equilibrium. But the moment you see there is a wave which is going, then each particle might be at different locations. The medium might get compressed or rarefied. Here I am just showing a wave on a string, that's it. I can also similarly show sound waves with different particles coming close and far, or a spring-like motion where spring is compressed and elongated alternatively, right? And this was your usual equilibrium position, which I call the x-axis. So here you can see if you choose any particle, let's say over here, it has some y position at certain distance x from the origin, and at different time that particle will go at different places. That means the motion of that particle will be like this. It will go like that and it will come down like this. It will go down, go up like that and come down like this. It will basically perform a nice simple harmonic motion if this is a sinusoidal wave. If this is a sinusoidal wave. Sinusoidal means the wave is a sine function, but there is no need that the wave is a sine function. It can be some random wave also, that's okay, but usually the waves that we study in our JEE physics is sinusoidal waves. So it is going to perform a simple harmonic motion, and you will see that the y coordinate is a function of both x as well as at what time are you looking at it. Because if you see, different x will have different y. This particle is at a different height, this different height, this different height, this negative, this different negative. So it depends on x and at what instant, because at the same place you will see the particle will keep going up and down. So the y coordinate will also keep on changing. The y coordinate will also keep on changing. Is that very clear? Now from this you can easily understand what will each of these terms give you. What will each of these terms give you? If I take the derivative of y coordinate with respect to time, it will give me what is the rate of change of y coordinate with respect to time, will give me the particle's velocity, If I take the second derivative of y with respect to time, then I will get the particle's acceleration. If I by chance take dy by dx, if I take dy by dx, what it tells me is if I draw a tangent, the rate of change of y with respect to x, it is just going to give me the rate of change of y with respect to x. So it is just going to give me the slope of the shape of the wave, of the particular wave which is traveling. Lastly, one more quantity which you should know is what will dx by dt give me? dx by dt, rate of change of x with respect to time. Rate of change of x with respect to time is how quickly the wave is traveling along the wave propagation. So it's just going to give me v, which is the speed of the wave, not to be confused with the particle velocity. Please remember, this particle velocity is the up and down motion, SHM motion. So this particle velocity will not be constant. It is not going to be constant. But this wave speed, this is going to be constant. Remember that. This is always going to be constant. Is that clear? Is that very clear? They are two different things. Do not ever confuse between them. Also remember, the maximum particle speed that you can get. There are two things over here. The maximum particle speed that you can get versus the minimum particle speed that you can get. Maximum and minimum. Minimum will be 0. Where will you get 0? At the extreme positions. Like a SHM, guys. Like a simple harmonic motion. At the extreme positions, the particle speed will be 0. And at the mean position, you will have a omega as the maximum speed. This is at mean position. You will get maximum speed. This will be the maximum speed that you can get at the mean position. This is just like SHM. A is amplitude, omega is the angular frequency. Same way over here also for acceleration, you can get the maximum acceleration. And you can also get the minimum acceleration. You can also get the minimum acceleration. Where will you get the minimum acceleration? The minimum acceleration will be at the mean position, and it will be obviously 0 in magnitude. The maximum acceleration you will get it at the extreme position, and that will be equal to a omega square, just like SHM, just like simple harmonic motion. Is that absolutely clear, my dear warriors? Yes. You can see the relationship between wave and SHM. All these topics are related to each other. Now, with regards to the wave speed, also remember the wave speed will can be also given in terms of the parameters which you use in the wave equation. We'll be coming to the wave equation in a bit. So it will have something x, something time, some equation will be there. So one way of writing the wave speed is writing it as f lambda. That is one way. You can write it as f lambda. If you don't like f lambda, you can write frequency as omega by 2 pi and lambda as 2 pi by k. So if you do that, frequency as omega by 2 pi and lambda as 2 pi by k, you will also get it as omega by k. This is another way of writing the wave speed. Omega is a constant, k is a constant. It's not spring constant, don't confuse. It is basically your angular wave number, the angle per unit length basically. Another way of writing it is the coefficient of time upon the coefficient of x. This is another way of writing it, coefficient of time upon coefficient of x. I'll come to that in a bit. What do I mean? Any wave equation will look like this, especially a sine or a cos equation. Amplitude, sine or cos, both can be there, doesn't matter. There is no hard and fast rule, you have to use sine only. Plus minus kx, plus minus omega t, anything. You can write omega t first, you can write kx first, you can write minus kx, you can write plus omega t. That all depends from wave to wave. And some constant, that constant is basically your phi. So instead of showing this slide, I'll just write it down for you over here in a simple way. Y is equal to, you can have a, you can have sine, or you can have cos, you can have kx plus omega t, kx minus omega t minus kx, omega t plus kx. So that's why plus minus over there. And you have a constant which is your phase constant. Keep this in mind. Now, when you see this equation, you will see there is a coefficient of time which is omega, coefficient of x which is k. So that is why I said coefficient of time which is omega, coefficient of x which is k. So that is how you can also write it as coefficient of time by coefficient of x. Is that absolutely clear? Okay. Now, when you have such a wave equation, you can also predict which direction it is moving by looking at the relative signs. Like for example, if it is kx plus omega t or minus kx minus omega t, which is the same as minus common and then kx plus omega t, right? In both these situations, both kx and omega t, both their signs are same. When the signs are same, basically the wave is traveling in the negative x-axis. Keep this in mind. But if, for example, it is kx minus omega t, or it is minus kx plus omega t, or omega t minus kx, or minus omega t plus kx, basically the signs are opposite, then the wave is traveling in the positive x-axis. Is that absolutely clear, my dear warriors? Soba 18, you don't have to take running notes, not mandatory, because you will get all these notes in the PDF form as a link after the session is over. But if you feel like that is always your cup of tea or this is how you learn, you can continue the same habit, but there is no need if you are not able to listen and write simultaneously. Okay, if you want to just listen, please do that because that is more important. But if you feel that you are more comfortable, continue with the same habit. Okay, clear. Is dy by dt and dy by dx the same? No, obviously not. Dy by dt is particle velocity which keeps changing. Dy by dx is the slope which is different at different points. One is slope of the wave, another one is the actual particle's velocity. Two different things. I hope this is very, very clear. Right. Now, similarly, you have electromagnetic wave, which is basically a light wave. This was for a wave on a string. For a wave on a string. This is how the equation looks like. For a electromagnetic, basically your light wave. For electromagnetic or light wave, what do you have? Number one, you have the electric field. You have the electric field which is continuously changing in one plane. Let's say I call this E. And simultaneously, you have the magnetic field which is changing like this. Okay, this is the magnetic field. Both of them are basically perpendicular to each other. Please keep that in mind. And the light wave as such, the direction of propagation is like this. This is a electromagnetic wave. This, if you see it from behind, you will see that the electric field is vibrating or oscillating in one particular plane. The magnetic field is oscillating in a perpendicular plane. I am seeing this from behind. Okay, and the wave as such is traveling in that perpendicular direction also. So let's say the wave is traveling like this with a speed of c. So all the three things are perpendicular: electric field, magnetic field, and the velocity of the light. Okay, this is very important. Now, if you look at the equation of the electric field, it will be something like this. E naught, sine you can have or cos you can have, doesn't matter. Again, plus minus kx plus minus omega t you can have, and this phase constant. Now, if you have this as the electric field, the magnetic field equation will look very similar. So it will be B. Instead of E naught, you will have B naught. What is E naught or B naught? It's the maximum electric field or the maximum magnetic field at that location. Maximum electric field or maximum magnetic field. Yes. They will sustain each other. Yes, Rakesh. Electric field produces magnetic field produces electric field. If you change electric field by Maxwell's equation, magnetic field is generated. If you move a magnet around it, electric field is created. So one creates the other. They mutually coexist like Pandu and Champa. If Pandu is there, Champa has to be there. If Champa is there, Pandu has to be there. Pandu can't stay alone, Champa can't stay alone, like that. So this is nothing but D naught sine. If you use sine here, use sine. If you use cos. Don't use cos here and use sine over here. That will not be correct. If you use plus kx, use plus kx. If you use minus kx, use minus kx. And same thing with plus minus over here, omega t plus phi. What is E naught and B naught? Those are nothing but your electric and magnetic field amplitudes, just like you had amplitude for the wave on a string. So basically the wave on a string, I just showed it to you over here. Where did it go? Yeah, this was like a wave on a string, right? Great. Moving ahead. Oh my God, what just happened? Yes, moving ahead. For sound waves, you need to be little bit careful. So why am I saying you need to be little bit careful is because if, for example, this is your x-axis and here I show the pressure, and let's say there is I show the medium also. Okay, can you see the molecules are close, again far away, again close. Basically here you have a compression, here you have a rarefaction, again a compression, and again a rarefaction. So at a compression the pressure is high, at rarefaction the pressure is low. If there was no wave at all, then what would happen is that the pressure would be constant everywhere. The pressure would be constant everywhere, and that would be the atmospheric pressure. So I'm just going to call it as the P0 value. But because there is sound which is traveling, sound wave which is traveling, there are pressure fluctuations. So there might be a wave like this, pressure increases. I'm just showing it correspondingly over here, and then it starts decreasing and it becomes the rarefied low pressure, and again it increases over here and again decreases over here, something like this. So this is a pressure wave which is traveling, pressure increases, decreases, and after some time this wave would have gone here. So you will see the compression has moved here, the rarefaction would have moved ahead. So that is how the alternate compressions and rarefactions travel in the medium like air, liquid, or even solid. Now over here, this particular term which is there, this is the amplitude of the pressure wave, often called as the PM value, which is the pressure amplitude. What is this called? This is called as the pressure amplitude, if you remember it correctly. This is called as the pressure amplitude. At any location, you take any location, let's say over here, the pressure at that point above the atmospheric pressure, the pressure at that point above the atmospheric pressure is called delta P, which is nothing but your excess pressure, and this is excess above the atmospheric pressure, and that delta P is given by that same PM you take over here, and here you can use again sine, or you can use even cos, it doesn't matter, sine or cos. Then this will become kx plus minus omega t plus phi. Kx plus minus omega t plus phi. So you can see the wave equation is very similar to electric or magnetic field or wave on a string equation. Just that instead of amplitude, you have pressure amplitude, which is PM. Yeah. Yes. Is the x-axis displacement? No. X-axis is not displacement. X-axis is the position. I'll come to displacement in a bit. Hold on for now. Another important thing which you should know is that each of these particles, let's say you choose any particle, these particles, because they are in a part of a longitudinal wave, the wave is going like this along the x-axis. These particles will go here and here. These particles will go back and forth. They are performing simple harmonic motion. They have their own displacements. It's not that this particle is continuously going there. See, the disturbance is traveling, the particle is not traveling. So they have their maximum displacement, which I call SM, which is often called as the displacement amplitude. And the displacement of any such particle along x-axis is given by SM. If you use sine, use cos here. If you use cos, then use sine over here. I'll come to that also in a bit. And then kx plus minus omega t plus phi. This is the displacement of the particle at any instant. The displacement is only limited to the amplitude of it. So once the particle is here, then it is here, then it is here, then it is here, stops, then it is here, it stops, and then it is coming back. So the particle keeps on moving back and forth, as the alternate compressions and rarefactions keep flowing through that region. So x is not the displacement, x is the position, where you are analyzing the pressure or the displacement. S is the displacement of the particle when it leaves its equilibrium position. It has left its house from the equilibrium and it is moving somewhere. So that S is relative to that particular original position. I hope this is clear. Why not minus kx? You can also put minus kx, there is no harm. You can put plus or minus. Here also you can put plus or minus. It depends, like I said, right? It depends on where or how the wave is going. If it is going this way or if it is going the other way. The relative sign is what that matters the most. Is that clear? Subrakanta, this was right. Now, why did I put sine here, cos here, sine here? Because the pressure and the displacements are perpendicular in phase. Pressure and displacement are perpendicular in phase. So let me mention that displacement and pressure have a phase difference. Phase difference of basically 90 degree or pi by 2 radian. That is something which you should again know about. If you are wondering, are these two related to each other? Yes, they are definitely related to each other. In fact, you can say that the pressure amplitude PM is nothing but BKSM. PM is BKSM. Alright? Everybody with me? PM is BKSM. Now you might be wondering, sir, SM I understand it is the maximum displacement. PM I understand it is the maximum pressure change. So what is this B and K? K you already know. My dear warriors. The value of K is nothing but your angular wave number. So that is your 2 pi by lambda. That is standard. What is this B, sir? This B is nothing but your bulk modulus. This is nothing but the bulk modulus of that particular medium. It is the bulk modulus of that particular medium in which it is traveling. Okay, right? How are they perpendicular? It happens via derivation. That derivation again is a complex one. You can check out Halley-Resnick if you want, or even H.C. Verma has it. So I prefer Halley-Resnick for especially this sound waves part, because the way or the manner in which they explain these derivations is really awesome. But now is not the time to go through those derivations. For now, just go through the final conclusions. If you want to prepare for advance after the mains, yes, then you have to go through all these derivations. You should know why this happens and all of that. Okay, there's a beautiful derivation for that too. Okay, it comes through derivation. You cannot predict it. It is perpendicular. Oh, it's natural. It's obvious. No, it's not obvious. Okay. Then over here also there is one thing which is perpendicular, which we already mentioned: electric field, magnetic field, and speed of light, but in a very peculiar manner. Meaning, if you take electric field vector and do a cross product with the magnetic field, then you get a vector which is parallel to the speed of light. Oops, I think I used different colors. 1 second. See, you are doing cross product and you are going to see that it is parallel. Who is parallel to what? If you want to see a vector which is parallel to the velocity of the light, then you take electric field. You take electric field and do a cross product with the magnetic field. You will see that it will be parallel to the speed of light. Example, electric field is in the x-axis. Magnetic field is in the y-axis at some instant. You do electric field cross magnetic field. Electric field cross magnetic field. The thumb will point towards you. That means the light is coming towards you. Here also when I drew it, I have taken care of that. Electric field is upwards. Magnetic field over here is towards you. So electric field cross magnetic field will make my thumb go towards the right. That is why I have shown speed of light towards the right side. Is that clear? So you can find some questions based on that as well. Right. Venkataramana Murthy, please don't spam. Definitely I'll try to make videos on that too. Don't worry about it. Okay. Moving on now to the speed of the wave. for all the three kinds, be it on a string, be it for sound, or be it for light. See, to understand this, let me give you a very simple flowchart which many students do not know, and this is going to tell you who changes what. If medium changes, does frequency change or wavelength change? If wavelength increases, does the frequency reduce or does the speed reduce? What happens exactly? So if you ever got confused regards to that, this simple trick by your Captain Shreyas Sir is going to help you. How? See, the medium through which the wave travels, always decides what? The speed of the wave. Always decides what? The speed of the wave. Keep this in mind. The source, oh my god, the source which is there, like my speaker or my vocal cords or somebody oscillating a string, or you throw a stone in water, ripples are generated. So the disturbance in that water is that source, right? So the source is what decides the frequency. Keep this in mind. And these two together, speed and frequency, end up deciding the wavelength. This is the correct flow chart. And yes, they are all related to each other. We know wave speed is frequency into wavelength. So now if somebody says that, hey, sound is traveling from air and it entered water, so the medium has changed. That means the V value will change. The speed will change. Has the source changed? No. The sound is still coming from the same source or the speaker or whosoever is shouting. So frequency won't change when the medium changed. So speed changed, frequency didn't change. So accordingly, wavelength will change as per the speed changes. Understood? Is it clear? Okay. Today you are shouting in in the class, and maybe it is very cold, it is humid or whatever. Tomorrow it is very warm, it is not at all humid. So the medium has changed, but you are still the same. If you are the same and you are shouting, you are the source, so the frequency will remain the same. What will change is the medium. If the medium changes, again speed will change, so wavelength will change, right? Again, in the same medium, if two different people are shouting, that means two different sources, medium is same, so speed will be same. So speed will not change, frequency will change, because two different people or two different speakers are emitting the sound, and that's how the wavelength will change. I hope this is very clear. Yep, this is the correct flow chart which many students do not know about. So now that you understand speed is dependent on medium, what are those medium parameters which decide? What are those medium parameters which decide the speed? So for a wave on a string, it is nothing but the root of tension by mass per unit length. What is this mu? Mass per unit length of the string. Mass per unit length of the string. Sometimes you can also write it as density into area of cross section. Remember, this is nothing but the tension in the string. How tight is the string and how heavy it is per unit length decides how fast it will move. If the tension is large, the speed will be good. If it is very heavy, bulky, it will be very difficult for the particles to move. So if mu increases, speed goes down. Is that right? Everybody with me? Keep all these things in your mind. Now, the formula for string is done. For sound, there are actually two formulas. One is the Newton's formula, where Newton predicted that the formula for speed of sound is nothing but root of P by rho, but it ended up being wrong because he assumed that the sound travels in a way that the air's expansion and contraction is isothermal. But that was proven to be wrong. It is not isothermal. Laplace found out that it is actually adiabatic in nature. So let me just put it on the other slide, maybe over here. So According to Newton, remember the speed of sound was root of gamma p by rho. This is assuming isothermal. But this was proven to be wrong. Who corrected him? Laplace. So that's why you have Laplace correction, and this Laplace correction gives you the correct formula for the speed of sound. And what is that formula for the speed of sound? It comes out to be root of gamma p by rho. This is assuming the process is adiabatic in nature. Whenever sound travels, compression and rarefaction happens. This happens so quickly that it cannot exchange the heat with the surroundings. So there is no time to exchange. Before you think, the next compression or rarefaction has arrived. So that is why it is adiabatic, because there is no heat give and take. You can also write this as gamma RT divided by M. But please keep this in mind. This is only for gas. If you have a liquid, then the speed of sound will be given by the bulk modulus divided by density. And if you have a solid, obviously even solids can transmit sound. Instead of bulk modulus, you have Young's modulus divided by density. The formulas more or less look the same. Bulk modulus, Young's modulus, gamma p by rho. Always some mass term is there below. Mass term, molecular weight, density. Even for waves on a string, you can see mass is there below. Tension, some elastic property is there on the top. So that is how you can remember that the formulas look very much identical. Is that clear? Similarly, when you talk about light or electromagnetic wave, keep this in mind. The speed of light, actually given by the symbol C, is 1 by root of permeability and permittivity's product. If the medium changes, mu and epsilon will change. If you are talking about vacuum, then this will be mu naught, this will be epsilon naught. So this is your permeability, and this is nothing but permittivity. Keep this in mind. So this permeability can become your relative permeability. You can write it like this actually. Permeability of any medium let's write it like this. Permeability of any medium is a relative permeability, right, into the permeability of free space. Similarly, permittivity of any particular medium is nothing but your dielectric constant, into permittivity of free space. So that is how this formula works. So it's always better to leave this as mu and epsilon, because if the medium changes, even the permittivity values will change, which you will put over here. Accordingly, you will find the speed of light. From this speed of light, you can also find the refractive index of that particular medium. Keep this in mind. You can also find refractive index. Also remember, this formula extends to E naught by B naught, which is also E by B. So if you are wondering, is it related to electric field and magnetic field? Yes, it is. It is also electric field by magnetic field amplitude, or just the instantaneous electric field by instantaneous magnetic field value. Keep these things in mind. Cool till this point. Shall we go ahead? Great. Perfect. So till now we have covered the speed, we have covered the wave equation, the different parameters of a wave, right? We have also seen the wave on a string equation, light wave equation, sound wave equation, pressure and displacement relationship, how electric field and magnetic field are related to each other. Also the flow chart for deciding the wavelength, Newton's and Laplace corrections, light wave speed equation with permittivity and permeability. Let's go to energy now and intensity. Let me give you that formula. Although I'm putting printed slides, this is for your reference. I'm also writing it for you so that it sticks in your mind for a longer time. See, whenever a wave travels, whenever we talk about progressive wave, what is happening? Energy is flowing. Energy is flowing. So at the end of the day, wave is nothing but progression of energy. Progression of energy. And where does the progression of energy happen? From the source to the destination. From the source to the destination. So definitely energy is flowing, and there are formulas for energy propagation for different waves. So when we talk about string, for a wave on a string, right, the average power, the average rate at which energy is being transmitted, average energy going per unit time, is given by half mu. Mu is mass per unit length of that wire or that rope or the string, half mu v, v is the wave speed, a square, which is amplitude square, and omega, which is angular frequencies square. So average power is half mass per unit length, wave speed, amplitude square, angular frequency square. That is the average rate of energy transfer. Needless to say, this will be in joules per second or in watts, joules per second or in watts. For sound, you generally do not use power, you generally use the term intensity, and intensity is nothing but like power per unit area, power which is traveling per unit area, how intense the sound energy is per unit time, per unit area. That is why power per unit area. It is nothing but half pm square by rho into V. That's it. Half pm square by rho V. Rho is the density, V is the wave speed, pm is the pressure amplitude, which I was talking about some time back. G1, what is adiabatic in this constant? I just told you, right? When sound travels, it includes compression and rarefaction. So when you compress and rarefy a gas, what will happen? Temperature changes can occur, exchange of heat can occur, but because the compression and rarefaction is so fast, there is no time for the heat to go in and out. So the derivation of the speed of sound includes the concept of elasticity and some thermal concepts. Then when you consider those thermal concepts, understand that you have to consider it as an adiabatic process, not isothermal. That is why the Laplace correction. Permeability is for magnetism, permittivity is for electricity. When electricity or magnetic field, they travel through some medium, let's say you bring a magnet in space, magnetic field is generated. But imagine you bring some wood or some copper or some aluminum or some stone, then the field lines have to penetrate through it. Some mediums allow the field lines to penetrate, in fact they might even enhance it. Some might oppose it, the field lines might become very weak. So that permittivity and permeability decide that whether the fields are going to become strong or whether they are going to become weak. And at the end of the day, light is an electromagnetic wave. Electric and magnetic fields are traveling. So these two properties decide how quickly the electric magnetic fields can travel in that medium. Else, if it does not allow, you will see that the field will not be able to travel so effectively and the speed will also reduce. I hope that is clear. All right. Definitely, sir, I'm going to the college daily, but even though to take Vedantu online, so I need your help. Definitely, Virakshana, definitely. I'm here every day for all of you. That's the reason why we came up with this 2-week challenge. And let me also remind you that if you are interested in taking more help, there is this I would say the fast filling last crash course which we have for 999 rupees. The link is there in the description box of this particular video only. So if you have not yet joined it, join it as you are watching the YouTube classes also. attend the YouTube classes, also register for this crash course. Reason is it is for a very low price. It is for a very low price. Okay, it is 999 rupees only. You can see the crash course link. I think it should be there here. Yes, crash course 2.0 is there for just 999 rupees. This includes advanced preparation. You can use it for BitSat, you can use it for EMSAT, you can use it for other CET examinations also. Complete access is there till your June, so that you can use these classes which has study material, everything. Okay, so use this. I would say it will be very beneficial because you might be wanting a lot of resources in the last moment especially. Okay, now regarding electromagnetic wave, what is the energy that we talk about, right? So for an electromagnetic wave, please bear this in mind. The amount of energy in electric field, is the amount of energy in the magnetic field also, and the total energy of a electromagnetic wave is the energy of the electric field plus the energy of the magnetic field in it. So what happens is the total energy becomes 2 times electric energy or 2 times of magnetic energy. These kind of questions have also come in the previous year papers. So electromagnetic wave has both electric field and magnetic field. The amount of energy in this and the amount of energy in that is equal. Okay, so the total energy, which is the sum of electric energy and magnetic energy, will be either 2 times of electric energy or 2 times of magnetic energy, one and the same thing. I hope this is clear. Now you can also write the electrical energy density is equal to the magnetic energy density from this particular equation. So electrical energy density is half epsilon naught E square, and magnetic energy density is nothing but half magnetic field square by mu naught. This is your energy density, which means energy per unit volume. Keep this in mind. Now when we talk about the total energy of the wave, the total energy of that particular wave, the formula for that is right over here. It is basically epsilon naught E RMS square, which is also B RMS square by mu naught. If you are wondering what this RMS is, this is not E naught, this is actually epsilon naught. It has not come out properly. ERMS is the root mean square, and the root mean square, if you remember alternating circuits, it is nothing but maximum amplitude by root 2. So it is basically E naught by root 2 square. So technically speaking, this formula comes out as epsilon naught. If you do E RMS square, it will also become E naught square. And that root 2 square will just become 2 over here. Similarly, for magnetism, this B RMS, magnetic field's RMS value, will be nothing but peak value, maximum value by root 2. But I have to square it. So you can also write this as B RMS square will make it B naught square, and root 2 square will make it 2. Mu naught is there as it is. This is the total energy density. in an electromagnetic wave. Okay, I hope this is very clear. Total energy density. Litiguti, that is the reason why we are giving all the recordings right now. You only watch those lectures which are important for the JEE preparation, because you can't complete everything. But for getting 90 percentile or 99 percentile, I had made a video long time back, which are the topics that you have to study. It's there on this channel. You can still search for it. All physics, chemistry, maths. only prioritize those topics and study that. Wholeheartedly complete the assignments, wholeheartedly give those tests. Okay, whichever topics you do not know, it's okay for now. We'll see what to do in the last week. For now, this particular 2 weeks, just focus on what you know or what you think you can complete, which is important from the exam weightage perspective. Okay, clear? So all these things are clear. Then we can start with some questions, my dear warriors. Ready for some questions? Ready for some questions? Veerashekhar, I am there on YouTube over here, plus I am there on Neat English also. So please don't expect me to be there everywhere. But remember, you have my replicas, our amazing teachers' replicas in the crash course, right? Because everybody would want every teacher everywhere. Humanly not possible. So our selection process of the teachers is also very intense. Even I take interviews, and we do not take teachers who are not from any normal college. Number one, all the teachers in Vedantu are from, good colleges like NITs, IITs, BITS, only that level only. Number one. Number two, the interview process is next level. Number three, teachers are experienced not just by years, but also in producing results. See, you might be a 10-year experienced teachers, but you have not produced results, then there is no point. Okay, so these teachers have been producing results every year. Number four is that these teachers are specifically chosen for crash course because you need a different mindset, different approach for the last few days. A teacher in the long-term batch teaches differently. In the crash course, teaches very differently because you have to give quality content, precise content in that duration. So that is how our teachers are. So I feel that you will enjoy, you will learn a lot. Right? Cool. So let's start with some questions, my dear students. The wave equation is given by this: the wavelength, the frequency, and the wave velocity, particle velocity, and acceleration at this and this time. Okay, let me just create a duplicate of this because I might need some space. Okay, so first of all, over here, you can compare and you can see what is each term. Amplitude is 0.05, you can see, which is outside. The coefficient of x is basically going to be k, and it is basically 10 pi by 2, which is basically 5 pi. Then the value of omega is the coefficient of time, which is 40 pi by 2, which is 40 pi by 2, which is basically 20 pi. The phase constant, you can see, is minus pi by 4. So the phase constant is minus pi by 4. So we have got all the basic necessities right now. So now we can find out the wavelength, frequency, and the wave speed, right? So to find the wavelength, just use k is nothing but 2 pi by lambda. So from this, what will you get? Lambda is equal to 2 pi by 5 pi. Pi cancels, it will become 2 by 5 of a meter. Omega is nothing but 2 pi into frequency. 2 pi, so if you want to find frequency, then what will you write? You will write it as 20 pi by 2 pi. Pi cancels, 20 by 2 is basically 10. So 10 hertz is the frequency. Then we also wanted the, wave speed. So wave speed is nothing but omega by k. Omega is nothing but 20 pi and k is nothing but 5 pi. So pi cancels, 20 by 5 is nothing but 4. So 4 meters per second is the wave speed. Is that clear? Everybody with me? Awesome. But that is not all. There is another question also in this. What is the particle velocity and acceleration at this time? So to find the particle velocity, use this formula, which is nothing but derivative of y with respect to time. When I differentiate it with respect to time, x is a constant. So what I will get is the derivative of a sine, here I have kx minus omega t plus phi. A is a constant, it is outside. Sine's derivative is basically cosine. So cos kx minus omega t plus phi. Inside part's derivative, keeping x as a constant except for time, because I am differentiating with time. This is 0. Omega t's derivative will be omega. Phi's derivative will be 0 because phi is a constant. So I think I should get minus omega outside. I should just get minus omega outside. Everybody with me on this? Everybody with me on this? Very good. So I have just taken the inside terms derivative with respect to time because I'm differentiating with respect to time. So this will become minus a omega cos kx minus omega t plus phi. Now you substitute everything. Amplitude is nothing but 0.05. Omega we just figured out before, it is 20 pi. So it is basically 20 pi. Then you take cos of whatever kx. Alright, so this whole thing, whatever is there inside, but substitute x as 0.5 and time as 0.05. So it will be pi by 2 and you have 10 into x is 0.5 minus, what is that? Omega, which is 40, and this is 0.05 minus pi by 4. I think you'll have to find the cos of this. It's not going to be very lengthy. Just do the simple thing. You will get the answer in terms of pi. So you should just know what is the cos of 30 degree, 45 degree, 60 degree, standard things. You will get the answer. I think you should get the answer as 2.2 meters per second. You should get the answer as 2.2 meters per second after substituting everything. Same thing you can also do for acceleration. Acceleration of the particle will be derivative of the velocity with respect to time. So when you differentiate velocity with respect to time, just see this. You are differentiating this term. So it will be minus a omega. Cos derivative is minus. So again it will become plus. Sine of this entire thing. When you again differentiate with respect to time, kx minus omega t, kx is a constant, phi is a constant, omega t's derivative, minus omega t's derivative will be minus omega. So again you will have minus omega outside. So it will be minus a omega square sine of whatever is there here. Substitute and you will get the acceleration. You shall get the acceleration close to 140 meters per second square. After substitution, you will get it close to 140 meters per second square. Is that clear how to solve these questions? Shall we go ahead? Very good. Awesome. Let's move. Yeah, if you are getting it as 5 pi by 4, very good. Okay, substitute and see if you are getting the exact same answer what we are written here. All right, moving on to the next question coming up on your screen. The string shown in the figure, oh, where is the figure? Anyways, let's just assume that it will be a sine wave only. Frequency 5 Hz, the amplitude of the motion is this, the wave speed is this. Furthermore, the wave is such that at y is equal to 0, x is equal to 0 and t is equal to 0. Determine angular frequency, wave number, expression of the wave function, the maximum transverse wave speed, the maximum transverse acceleration, and all these things. Okay, so not that difficult. I'll tell you what. Over here, the frequency is 5 Hz. Frequency is 5 Hz. Amplitude is 12 centimeters. So let's do everything in centimeters only. Amplitude is 12 centimeters, CGS units. Wave speed is 20 meters. 20 meters is how many centimeters? Multiply by 100. So it will be nothing but 2 or 20 into 100 centimeters per second, which is basically 2000 centimeters per second. That is your wave speed. And y is 0, x is 0, t is 0. This will be useful for phase determination, nothing else. Question is angular frequency and other stuff. So start off with whatever you know. V is equal to f lambda. V is basically 2000. Frequency is basically 5. So what will lambda be? What will lambda be? It will be nothing but 2000 divided by 5. So therefore lambda will be 400 centimeters, 400 centimeters, which is 4 meters. That is the wavelength. Everybody with me on this? Till this point everything is clear, right? Okay. Very good. So once lambda is obtained, we can find angular wave number and all that also. Okay, so wave number is asked, not angular wave number. So if it was angular wave number, it was 2 pi by lambda. So 1 by lambda is also called as just the wave number. Angular wave number means 2 pi. If there is no angular word mentioned, then it is just 1 by lambda. So it is 1 by 4 of a meter, which is basically 0.25 per meter. 0.25 per meter. Is that clear? Is that clear? If they asked you the value of k, then it would have been 2 pi by lambda, which is 2 pi by 4, which is pi by 2 radian per meter. Pi by 2 radian per meter. Next important step over here, they have also asked you what is the angular frequency. So frequency is known, omega can be found out easily. Omega is 2 pi f, so it is 2 pi into 5, so it is basically 10 pi radians per second. So that is the value of omega. So omega also I found, wave number, angular wave number also I found. In fact, before going to C, we can also find E first. C is all we can find D and E both. We can find D and E both. How? I'll tell you. For this particular D as well as E, the particle's speed and acceleration is just like SHM. So if you know maximum speed of SHM or maximum acceleration of SHM, you automatically know the speed of the maximum speed and maximum acceleration of the particle, because it is going up and down, SHM only. So VP max is nothing but A omega. Amplitude is 12. Omega is 10 pi. Radians per second. So this will be 120 pi centimeters per second square. 120 pi centimeters per second square. Similarly, AP max, maximum acceleration is A omega square. Amplitude is 12. Omega is 10 pi. So 10 pi square. So this will make it 100. 100 into 12 is 1200 pi square centimeter per second square. Sorry, this was not second square. This was just centimeters per second. This was speed, right? Yeah, that's it. So VP max is this much. AP max is this much. Is that clear, my dear warriors? Very good. Very good. Excellent. Lastly, we can go to the part C also of the problem. We can also solve the part C of the problem. For part number C, expression of the wave function, y will be amplitude. Amplitude is 12 centimeters. Here you will have, let's say, sine. Then kx. K is nothing but pi by 2. And then x. Which way is it going? It's shown in the figure, but the figure only is not there. Assuming it is going in the positive direction of x, it will have minus term. If it is going in the negative direction of x, it will have plus term. So I don't think it is mentioned which side the wave is going. So I'll just put plus, or it could be minus. Omega will be nothing but 10 pi. What will be the value of phi over here? For that, look at this information. Y is 0, x is 0, time is 0. This clearly tells me phi will be 0, because in this expression, if you put x as 0 and time also as 0, then sine of 0 should be 0. So there should be no constant term over here. So it should be plus 0 only. So your final wave equation will just have over here 10 pi and t. That's it. The value of phi comes out as 0. Is that absolutely clear how you made this wave equation? Everyone, shall we proceed ahead to the next question coming up on the screen? Ready? Game ready? Okay, right. Let's move on to the next one. Okay, there is a string which is holding a mass. The lift, I think, is at rest, and next time the lift is going up with 30 meters per second square. Mass per unit length, everything is mentioned. Question is find the wave speed. So I feel you should know the tension at both the cases. When the lift is at rest, tension is just mg. So it will be mass, which is 0.4 into 10, which is basically 4 Newton. In the second case, the tension is only going to be different. The tension will be m into g, assuming it is moving up, plus a. So 0.4 into 10 plus 30, which is 40. So decimal goes, so 4 4s are 16. So 16 Newton will be the answer for tension. But that's not the question. Question is finding the wave speed. Remember, the wave speed formula is root of tension by mu. Is the mu given? I think we can calculate the value of mu over here. Mu is mass per unit length. Mass is 10 gram. So 10 into 10 to the power minus 3 upon this is 1 centimeter, which is 10 to the power minus 2 meters. 10 to the power minus 2, 10 to the power minus 2 goes, 1 10 to the power minus 1 remains. So it will become 1 kg per meter. 1 kg per meter. Perfect. So finding the wave speed becomes very straightforward. Wave speed is root of tension by mu. Tension is 4 by mu. So it will become 2. Here, when you find the wave speed, root of tension, which is 16 by mu. So it will just become 4. So the answer will be 2 and 4. Answer will be 2 and 4 meters per second. Is that very, very clear? Yep. Awesome. Let's move ahead. Let's move ahead. Right? Let's move ahead to the next question coming up on your screen. Now, this is a question on sound wave. It is given that the pressure is 0.02 sine 3000 t minus 9x, where all variables are in SI units. Okay. Find the frequency, the wavelength, the speed of sound, etc. The equilibrium pressure is this much. What is the maximum and minimum pressure at a point as the wave passes through that? Okay. So, first of all, this equation of sound wave is the excess pressure equation. Always remember that. It is not the actual pressure. If you remember, excess pressure is different from the actual pressure, like I had shown you over here, right? See this. This is excess pressure above the atmospheric pressure. The actual pressure over there is this value plus this value will give me the total value. So whatever equation is usually given is for the pressure which is excess or above the atmospheric pressure. So over here, do I know certain values? Yes. PM is 0.02. Omega is basically 3000. K value is basically 9. All right. Equilibrium pressure P naught is basically 10 to the power 5. Right. What is the frequency? So for the word frequency, you have to find F, and that will be obviously from omega. So over here, omega is basically 2 pi F. So therefore, F will be omega by 2 pi. Omega is 3000, 2 pi as it is over here. Therefore, F will be, this will become 1500 divided by pi hertz. 1500 divided by pi hertz. Next, so frequency part is done. Wavelength. How do I find wavelength? K value is given to me. So from that I can find the wavelength. K is nothing but 2 pi divided by lambda. Therefore, wavelength is 2 pi divided by K. K is basically 9. So 2 pi by 9 meters is the answer for wavelength. Cool. Now what about wave speed? So for the term wave speed, we can just do one thing. I know omega, I know K. So just divide omega with K. Omega is basically 3000. This is divided by 9. 3 goes 1 times and this will go 3 times. So this will become 1000 by 3 meters per second. That is your wave speed. Is that clear, my dear warriors? Till this point? Very good. Now what do you do next? Okay, this is also done. Equilibrium pressure is this much. What is the maximum and minimum pressure at a point as the wave passes? See, I know the pressure amplitude. I know the atmospheric pressure. So for the maximum pressure, so for basically maximum pressure, it will be P naught plus PM. P naught is the atmospheric pressure. Above that, how much is that excess pressure? Maximum possible. That is pressure amplitude, which is 0.02, right? So it will be nothing but 10 to the power 5 plus 0.02. If you talk about the minimum pressure, it will be nothing but P naught minus PM. So it will be 10 to the power 5 minus 0.02, right? So these are the maximum and minimum pressures at a point as the wave passes through. As simple as that. Great. Great. Perfect. Cool, guys. Everyone. Till this point, everything clear? Let's move on. Okay. So let's move on to the next question. All these things I have also put it up in the printed format. Let's move on to the next one. Here, a sound wave of certain wavelength the difference between maximum and minimum pressures is this much. Find the amplitude of the vibration of the particles if the bulk modulus is this much. Interesting question. Very, very nice question. Sound's wavelength is given, bulk modulus is given, the difference is given. Find the amplitude of the basically vibration. See, if the difference is given, to be 4 into 10 to the power minus 3, this difference, keep in mind, is actually double of the pressure amplitude. This is actually 2 times of PM. So technically PM is just 2 into 10 to the power minus 3 Newton per meter square. 2 into 10 to the power minus 3 Newton per meter square. And do not forget that PM is BKSM. PM is BKSM. PM is 2 into 10 to the power minus 3. Bulk modulus 1.4 10 to the power 5. Angular wave number is 2 pi divided by lambda. What is wavelength? Wavelength is 40 centimeter or 0.4 meter into SM. That's it. Everything you know, you have substituted. Only one unknown, which is SM. Multiply, divide, and you will get the answer close to 0.91 into 10 to the power minus 9. That's very, very small. So close to 0.91 into 10 to the power minus 9 meter or 0.91. This is nanometer. This is nanometers. That's how small the displacements are when sound travels through a medium. Don't expect it to be in meters or even in centimeters. Is that okay? Yes. No, theory part is not complete. There is a lot of theory left, bacha. Okay, this is just the first part. Right? After this, we are going to go to interference, and then we'll go to the 2 special parts as well, which is your beats, then organ pipes, YDSC, and also your polarization and all of that, right? Diffraction. Right. Moving on to the next question coming up on your screen. The speed of sound in air is this much. What is the speed of sound in hydrogen at NTP if the density of hydrogen at NTP is 1/16th to that of air? So, which is the formula that we are going to use? Is there a formula which will help us in this problem? It is clearly mentioned, it is NTP. That means pressure is going to be the same, the quality of the gas is different. So why not use this? V is equal to your gamma P by rho, and because density is mentioned, right? So I think let's keep density also in the formula. Gamma for sound in air and in hydrogen. Okay, the gamma value will be different. The gamma value will be different. Yes or no? The gamma value will be different, right? So we need to be little bit careful about that over here. If it is monoatomic and then diatomic. But if you carefully analyze, air is a mixture of mainly diatomic gases. Monoatomic gases are hardly present. So the gamma of air is mainly the gamma of diatomic. And hydrogen is anyways not a mono, it is a diatomic gas, H2. It exists as a molecule. So the gamma for air and hydrogen is coincidentally the same. That is one good thing. So gamma for air is gamma for H2 because both are diatomic gases. The pressure is also the same because it is clearly mentioned NTP values. So therefore the speed is inversely proportional to the root of density. Right? Now the question is, what is the speed of hydrogen? The speed of hydrogen upon speed of air will be density of hydrogen below and density of air on the top. Since the density of hydrogen is 1/16th to that of air, so air is 16 times heavier than hydrogen density wise. So the speed of hydrogen will be root 16, which is basically 4 into the speed of sound in air. So 4 into 332. How much does it come out to be? My dear warriors? Does it come out to be 1328? multiply 332 with 4, you should get it as 1328. 1328, yes, meters per second. That is what it will be. As simple as that. Okay, so this is a question on sound waves speed formula. You should know when is gamma different, when is gamma same. It could be like argon gas is there, or neon gas is there, and helium or let's say hydrogen gas is there. So one is mono, one is dia, so gamma will be different. So in this, you will also see gamma's ratio will come. Be very careful if gamma is different. Be very careful if gamma is different, right? They can trap you like that. Moving on to the next question, my dear warriors. There is an electromagnetic wave of certain frequency is going along the z-axis. Amplitude of the field is this much, permittivity is this much, average energy density of the field will be how much? Average energy density of the field, electric field will be how much? Now you need to be little bit careful over here. The total energy density is half epsilon naught E naught square. But remember, this total energy density is 2 times of electrical energy density. So therefore, the electrical energy density, take that 2 below, it will become 1 by 4 epsilon naught E naught square. So now you substitute and see what is the answer that you get. Permittivity is 8.8 into 10 to the power minus 12 into electric field value, maximum value, amplitude is 4. So basically into 4 square. So one of the 4 will get cancelled. 4 into 8.8 and you have 10 to the power minus 12. You should get 35.2. Yes, close to that. Very nice. See if you get the answer as option C, 35.2 into 10 to the power minus 12 joules per meter cube. This is energy density. Many people forgot the 4 here. They wrote 2 because they did not read the question carefully in 2014. They forgot this word electric. If it was total, then you will use half. If it is either magnetic or electric, then you have to use 1 by 4 because half energy is electric, half energy is magnetic. Right? Everybody with me? Cool. Let's move on to the next question coming up on your screen, and here it is. A plane electromagnetic wave of frequency this much travels in free space in the x direction. At certain point, this is the electric field. The value of the magnetic field at that point is how much? Okay. See what happens. If I know electric field, I can find magnetic field using this formula. Electric field by magnetic field is C. So I want to find the magnetic field. So it will be electric field by C. Electric field is 9.6. Speed of light is 3 into 10 to the power 8. Divide this with 3. This will become 3.2 into 10 to the power minus 8 Tesla. 3.2 into 10 to the power minus 8 Tesla. Now you can see B also and D also both have the same magnitudes, but the directions are different. So here you take into account this formula. Electric field cross magnetic field is parallel to the speed of light. Electric field is in J cap. Speed of light, it's in X direction, that means I cap. So J cross what will be parallel to I cap? J cross what will be parallel to I cap, guys? I, J, K. J cross K will be I. So it will be basically K cap. So hence K cap will be there in the answer, which is option number D. Which is option number D. Is that clear? This is how you had to solve this particular question. Very good. Looks like many people like theory more than problem solving. And that's why I can see the attendance changing also accordingly. So whenever theory comes, people are like, yes sir, theory I'm learning more. But that is exactly the mistake which many students do. They forget that just learning theory is of no use unless you apply that theory in problem solving. Even if you feel that the problem is hard, or if you feel that how can I even think about this question in the examination, remember this is what you need to see right now, problem solving, which is what is actually going to help you. Okay, just learning the theory, you are going to face the same issue in the examination because this is like JEE Mains. This is same JEE Mains level only. So if you can't solve it here, it will be very difficult to solve it in the exam, considering there are other factors like nervousness, the exam hall tension, which is going to come into play. Yeah, correct. Let's go on now to the next part. This is here done, I believe. Yeah, interference. Let's go to interference. Young's double slit experiment, beats, all those things. Okay. Gryffindor, I would say just watch the same formula session. No, that will be better. I mean, again, I'll do the same thing. How will it be different? Why won't the old formula session be useful? Is it the syllabus which has been changed? Or you just want to see me live, sir? You do it again. Just watch the same recording again. Trust me, it is a very beautiful video. I put in a lot of effort in that. Okay. It's not that I don't want to put in the same effort. The thing is, I can utilize that time for some different thing. Maybe a different mock test, unseen problems, some PYQ problem solving session. I can better utilize it right now for the second attempt. You already have that video. Okay. Cool. So what is interference? Interference is when two or more waves come and meet at a point, and each one of them imposes their effect, their displacement, their whatever physical quantity, they add up with each other and they produce a resultant wave. So you might have two people talking at the same time. What you hear is not any one of them, but you hear the resultant of both of them. You drop two stones in water, the ripples will meet at some point. You will see there is a resultant motion which is produced, which is called as the resultant wave. You will see the intensity, the amplitude, everything will be different of the resultant wave. And there are formulas for finding them out too, don't worry. Now, whenever two or more waves interfere, you might get sustained or not sustained interference. What is the meaning of this? Sustain means you are maintaining it continuously, it is constant. If you see it now, if you see it after 1 hour also, it is the same. So, there are few conditions when you see sustained interference, and that is what you have in JEE also. Like, the two sources should be coherent, meaning the two sources should have constant phase difference. Let's say one is emitting crest, other is emitting trough. It is coherent source. It's not that both should be emitting crest. I'm saying one is crest, one is trough. And when next instant happens and this is emitting trough, this should emit crest. Again, this will be crest, this will be trough. Trough, crest, crest, trough. Trough, crest, crest, trough. The relationship is constant. You can predict what is happening. It is maintaining a constant phase difference. That is coherent. When I'm singing sa, I know other person is singing, let's say ka. I go to ka, I know the other person is singing sa. So I know there is a constant relation between both of us. We are then coherent sources. Understand that. Okay. It could be also that both are emitting crest, both are emitting trough, both are emitting crest, both are emitting trough continuously. Then it is coherent. Incoherent means this is crest, this is crest. When this is trough, this is still crest. When this is crest, again it is trough. Again when this is trough, this might be crest. Again this goes like this. This is like this. This is like this. Then it is not there. Sometimes this is there. This is only not there. It is random. So that is incoherence. There is no systematic relationship. There is no phase which is maintained between the two waves. That is incoherent. The two sources must emit waves continuously of the same wavelength and frequency. Yes, the lambda should be same, the f should be same, and it should be continuous. Meaning, imagine one source is sending the wave, other source didn't even send its wave. What interference will occur? Again, when this guy is sending, this guy is silent. Then again, what interference will happen? So there should be continuous wavelengths which are coming out. You will also see the separation between the sources should be generally small. You will see because if the wavelength is large, then it's very difficult to find the interference, especially with regards to light. Basically, the distances should be comparable to the wavelengths. If it is sound, wavelength is huge, you can keep the source is 1-2 meters, few meters apart. If it is light, then the wavelength is only in nanometers, so the sources should also be placed very, very close to each other. Also, when you are trying to see the interference, you will try to measure that interference. Like for light, the screen is kept at a decent distance, not very far, because when you go very far, the intensity will only go off. Like for sound also, if you are trying to measure the interference very, very far, sound will die out by the time you reach there. That is more of common sense. If you want a good contrast between maxima and minima, amplitude should be very close to each other and the background should be dark. For light, for sound, the background means there should be no other noise which is coming on. Say, what does it mean? When two or more waves meet, they can meet like this. Crests come together and troughs come together. That will be constructive, meaning maximum energy gets added up, maximum amplitude is created, and you will see this is called as maxima. If it is light, you will get a bright region. If it is sound, you will hear loud sound. Okay, so that is constructive. Destructive means a crest comes with a trough or a trough comes with a crest. Okay, so they will cancel each other out, and at that point the energy which you get is very low, amplitude is very low, and if the waves cancel each other perfectly, it is called as a perfectly destructive interference. And if it is light, you will not be able to see anything over there even though the waves come over there. If it is sound, you will not be able to hear anything. That is how the difference is for sound as well as light. Otherwise, the theory is the same. If you want a good contrast, meaning you want very loud sound at constructive and negligible sound at destructive, or you want very bright region and very dark region in case of light, then ensure both the amplitudes are roughly equal, because when they meet, you will see they will perfectly cancel each other at the destructive interference. Or else, if they don't cancel each other properly, then you will be like, I can still hear something, I can still see something. The contrast won't be there. If you want many fringes for light, okay, interference, or you want many places where you can see or hear loud sound, no sound, loud sound, no sound, maxima, minima, then the sources should be narrow and monochromatic. This is basically because when you place the sources close by, then you will see multiple fringes, multiple interferences occur at different places. And monochromatic means single source, because if you have multiple sources, then they will all overlap with each other. It will be a complete mess. It will be a complete screw up of the entire thing. Many interferences will combine together and you will not be able to clearly see it. That is why you use generally monochromatic light. Okay, very good. So, having said this, I have just told you about coherent and incoherent sources. I'll just mention for coherent, it can be either like this. They are said to be coherent. This is one example. Another example, it is like this. This is also coherent. Another example. Oops, sorry. This is also coherent. Incoherent examples. The wave is broken. It's not there only. Another example. Frequency or the wavelength is changing, right? Or another example, something like this. This is there, again this is there, sometimes this is there, okay, then this is there like this. So these are all incoherent sources. Something randomly is happening. There is no consistency, right? You should know all these things. So let's talk about the interference formulas which are there, which you must definitely know. First of all, I can give you the direct slide also, but I feel I will write it down. That will be better. Then we can directly go to some problems. Observe this. For coherent sources, if these are the two waves coming in like this, there is a difference between their paths, that is called as the path difference, right? Then you can get the term called as the phase difference, delta phi, which is given by 2 pi by lambda into delta x. 2 pi by lambda into delta x gives you the phase difference between the two waves. Once you know the phase difference, if this particular wave has an amplitude A1, another wave has an amplitude A2, you draw the phasor diagram wherein you take the amplitudes as vectors and show those vectors relative to each other, making the exact angle as their phase difference. So if you show one of the phasor like this, let's say A1, show the other phasor, let's say amplitude A2, making an angle over here, which is delta phi. You have to show them like vectors. The angle is the phase difference. Now simply do vector addition. So use your triangle law or parallelogram law, whichever law you want to use, and then find the resultant. This is the amplitude of the resultant wave. So always remember, the amplitude of the resultant wave is the vector sum of the phasors of the waves which are interfering. So if you look at the magnitude of this, AR will be root of, use the vector formula, A1 square plus A2 square plus 2 A1 A2. Here you will have cos delta phi. Alright, same formula which was there in vectors, a square plus b square plus 2ab cos theta. If you talk about the intensity or the energy of the wave, it could be intensity or basically power of the resultant wave. The formula for that is looking very similar but slightly different. Instead of root, there is I1 plus I2 plus 2. Root is there here, I1, I2, and cos is there outside the root. This is for intensity or for power. I1 is the intensity of first wave, I2 is the intensity of the second wave, IR is the intensity of the resultant wave. Keep these things in mind. Also, please bear this in mind that your intensity or power are always proportional to the square of the amplitude. This was always true, be it for electromagnetic, light, sound, wave on a string, ripples of water, earthquake wave, sea wave, every wave follows this relationship. Okay, now these are general rules or general formulas which you can use, but there are specific formulas for special interferences as well. Like for example, when we have constructive versus destructive interference. So these two waves are added to give you a large amplitude. So let's say this is A1, let's say this is A2. The amplitude of this will be A1 plus A2. This is going to be your constructive interference. Similarly, you can also have destructive interference. If this is A1, this is A2, when you add both of them, what you might get is a wave of a little bit smaller amplitude. So it is A1 minus A2 mod of it, because I don't know who is big, who is small. In such cases, you will see that the path difference will be n lambda, basically 0, lambda, 2 lambda, so on and so forth. Whereas the phase difference will be basically even multiple of pi, which means 0, 2 pi, then 4 pi, and so on and so forth. You will see that the amplitude is just the addition of them. the intensity of the light or the intensity of the sound will be maximum, and it will be given by root I1 plus root I2 whole square. Root I1 plus root I2 whole square. That is for constructive. For destructive, the path difference will be odd multiples of lambda by 2, which means lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, 9 lambda by 2, like that. And the phase difference will be odd multiples of pi. Everything is odd over here. So it will be either pi, 3 pi, 5 pi, 7 pi, like that. And the intensity of the light or the sound is minimum. Formula is very similar. Root I1 minus root I2 whole square. Instead of plus, you will get minus over here. That's the major difference. Is that clear? Yes. Difference between phase difference and part difference. Number one, unit. Phase difference is always in radians. Part difference is in meters. Part difference is the actual difference of the path of the two waves which are meeting. Maybe, say for example, if I have to tell you, one source is here, the light is coming like this. Another source is here, the light is coming like this. Or maybe it's here, the light is coming like this. Maybe this is 2 meters, maybe this is 5 meters in length. This is 2 meters and 5 meters in length. This is source number 2, this is source number 1. This is the point where they are meeting. So at that point, delta x will be 5 minus 2, which is basically 3 meters. That is the meaning of part difference. Phase difference is, if you draw the phasor diagram, if one of the phasor is like this, the other phasor might be shifted by some angle. Maybe one is having a crest, the other is having a trough. So they are opposite in phase. Phase difference is 180 degree. So it is in angular terms, in terms of phasor diagram. Okay, there are two different things. So when maybe S1's maybe crest is coming, maybe the crest of one is coming. Example, I am saying, maybe the trough of the two is coming. The trough of the 2 is coming. So that means from this piece of information, the phase difference is pi radian. That is the meaning of phase difference. Is that clear? Everybody with me on this? Shall we go ahead? Shall we go ahead? Yep, very good. So all these things I have also put it up over here as well in the printed form, but you can also refer to this as well. Now, one important thing which many people do not know is, let me put here, when you have incoherent sources, interference of incoherent sources. This part many people forget when it is incoherent. Then if there are multiple sources, S1, S2, etc., they are emitting sounds at this particular point, or it could be light also, then the intensity of the resultant is not I1 plus I2 plus 2 root I1 I2. It's just I1 plus I2. There is no term over here. If there are 3 sources, for example, S1, S2, S3, and all these sources are producing waves which are interfering, then it will be just I1 plus I2 plus I3. The intensities will add. Please do not add amplitudes. That will be stupidity. AR is not A1 plus A2 plus A3. Understand that. This is not true. Intensities will add. So this is the correct formula that you will use only for incoherent sources. There is no phase difference over there. Okay? There is no phase difference over there. Keep this in mind. Clear? Shall we do some questions now? Shall we do some questions? Okay. Coming up on your screen, here it is. JEE Mains 2020. 3 waves having equal frequencies and same intensities have phase angle 0, pi by 4 and minus pi by 4. When they are superimposed, the intensity of the resultant wave is close to, what do you think? What do you think? 0, pi by 4 and minus pi by 4 are the phase angles of the 3 waves of same frequency, same wavelength, same intensity when you get the resultant, what will happen? Remember, whenever you have to find the resultant, just treat them like vectors and add it normally. Imagine one of the waves, I show the amplitude to be like this. Let's say I call it A naught. The other wave has a phase angle of pi by 4. So let's say 45 degrees over here is the other wave of amplitude A naught. Other wave is minus pi by 4. That means it will be here, and this will be also A naught. All of them have same amplitudes. Obviously, this is 90 degree. These are vectors. So first, let me take care of these two perpendicular ones because their resultant will be in this direction. So I will get a resultant of these two like this, which is going to be root 2 times of A naught. And this A naught will come over here as it is over here. Correct? This is what I have transformed it into from this to this diagram. Now I can further combine it into one single vector, and that will be nothing but A naught into 1 plus root 2. A naught into 1 plus root 2. This is your resultant amplitude. This is your resultant amplitude. Till this point, everything is clear? Till this point, everything is clear, my dear warriors? Very good. Now, what is the question? The question is not on amplitude. The question is on intensity. Read the question carefully. The intensity of the resultant wave. So we need to use the fact that intensity is directly proportional to amplitude square. Be careful of it. So the intensity of the resultant wave upon intensity of any wave is amplitude ratio square. Amplitude is A naught 1 plus root 2, and original amplitude was A naught only for any of the waves. A naught cancels, so this will become 1 plus root 2's square, which is nothing but 1 plus 2 plus 2 root 2, which is 3 plus 2 root 2. Root 2 is 1.4. 1.4 into 2 is 2.8. 2.8 plus 3 is 5.8. So 5.8 is the ratio of resultant wave upon original wave's intensity. So IR will be 5.8 I naught, which is option number A. It was a 2020 question. How many of you loved the question? How many of you learnt a lot? This is how you relate intensity and amplitude. Yeah, this is how you add two or more waves, find the resultant, treating them like vectors. That's all I have done. Shall we proceed? Shall we proceed, guys? Yep. Ready for the next one? Okay. Here comes the next question on your screen. Equations of the two waves are given as follows. The waves are simultaneously passing through a string. The amplitude of the resultant wave. Simple, guys. Look at this. Two wave equations are given. And the question says, find the amplitude of the resultant wave. First wave's amplitude, A1, just look at it, it is 5. Second wave's amplitude, look at it, it is basically 3. Phase difference is right over here, if you notice carefully, 2 pi into 1.5. Phase difference is actually there. This is also sine, but this extra term which is there, 2 pi into 1.5, 1.5 is 3 by 2, so it will be 6 pi by 2. 6 pi by 2. 6 pi by 2 or 2 pi into 1.5, I might as well write like this, 2 pi plus 0.5 into 2 pi. One and the same thing. 2 pi plus 0.5 into 2 pi, right? 1, I have split it into 1 plus 0.5. Now, this 2 pi will not matter only because when you complete one revolution, right, it is back to the original thing. So, it is numerically equal to 0.5 into 2 pi trigonometry wise. So, this is nothing but just equal to pi. Oh, pi means they are opposite in phase. Opposite in phase. That means there will be destructive interference. Destructive interference. So what will happen to the resultant amplitude? It will be A1 minus A2 modulus of it. So it will be 5 minus 3, which is basically 2. So 5 minus 3, which is basically 2, which is option number A. Got it, my dear students? Everyone? So this is how simple the questions are. Okay? This is how questions have been asked in the previous years. I'm giving you the theory, I'm giving you the concepts, I'm making you apply those concepts in these problems. That's all. Because if you see me doing it, you will get that confidence. You see a teacher doing it, you will learn a lot. You might read the book, you might not understand. And you would have actually tried this out on your own, maybe before coming to this lecture, that you tried understanding this chapter, how to solve the problems. But when you see somebody doing it, that too properly, you will definitely get that confidence. Next one. Interference is observed on, due to the two sources coherent with zero phase difference, okay, separated by a distance of 4 lambda. A and B, they are two sources. They are emitting sounds or light simultaneously. Their separation is 4 times their wavelength of the sound or light, whatever they are producing, okay. Now, a detector D is being moved on the x-axis. This is a standard type of question which has been asked many times. Number of points on the x-axis excluding the point 0 and infinity where maximum will be observed. Where maximum will be observed. Okay. Now, I'll tell you, this problem can be solved orally also, but it's okay. I'll explain this to you properly. See, what you need to understand is whenever maximum will be observed, the path difference, maximum will be observed, the path difference will be n times of lambda. Some integer times of lambda, 1 lambda, 2 lambda, 3 lambda, 4 lambda, something lambda. Okay. Now, next thing, where will you get those points and how many are they? That is what we need to think. Okay, let's go right from here and slowly start moving away. Let's say point D is very, very close. Point D is very, very close. So, one of the wave comes like this and the other wave hardly travels anything. Next, you go little bit far away, then you reach here and this has to reach this much. Then you go little bit more far away, then you have to reach here and this has to travel this much. You go even more far away, then what happens? You have to go almost like this and this wave has to travel like that. We are very, very far away. From this, probably you are getting some idea of what is happening to the path difference. When you are very, very close, then one of the wave is traveling like this, the other wave is hardly traveling anything at all. So when this distance BD tends to 0, that is when you are very close over here, what is the path difference from these two sources? What is the path difference from these two sources? I think it will be equal to the separation between them. I think the separation is already mentioned. How much is the separation mentioned to be? How much is the separation mentioned to be? It is mentioned to be 4 times of lambda. 4 times of lambda. So can I say the path difference is close to 4 lambda? Is close to 4 lambda. One wave travels 4 lambda, other wave hardly has traveled anything. When you go really, really far away, then one of the wave will go like this, another wave will also go like this, and they will meet at infinity. Both these waves will meet at infinity, right? So when your distance B to D tends to infinity, both these waves travel infinitely long distance, but they are parallel to each other, right? They are parallel to each other. So what is their path difference going to be? Their path difference is going to be 0. Their path difference is going to be 0. So now I think I have figured out most of the parts of the problem. When you are really far, path difference is 0. When you are really close, the path difference is 4 lambda. That means if I travel on the x-axis starting from the origin, which is at point B, I will get 4 lambda path difference here, and at infinity I will get 0 path difference. Somewhere in between I will get the remaining path differences, like I will get lambda over here, maybe I will get 2 lambda over here, maybe I will get 3 lambda over here, and finally 4 lambda. These are basically 3 points of constructive interference. 3 points of constructive, or basically maxima. 3 points of maxima that I am getting. Is that clear? So hence the answer should be 3 maximas. Clear how we solved it? You took the extremities. Once you are here, once you are really far. What is the path difference here? What is the path difference here? You got the extreme points. So all other numbers will be in between that. Between 0 and 4 lambda, you should get lambda, 2 lambda and 3 lambda. Don't include this and this. So these three only you have to consider. So 3 lambdas over there. Is that right, everyone? Clearly understood? Shall we go ahead? Shall we go ahead now? Perfect, perfect, perfect. Great. Let's move on. Let's move on, guys, to the next question coming up on your screen. Right. Two beams of intensities in the ratio 9:4 are allowed to interfere. The ratio of the intensity of maxima and minima will be. Ratio of the intensity of maxima and minima will be. Okay. Intensities of the lights which are interfering is given. I1, I2 ratio is given. What is the ratio of maxima and minima? Imagine one of the lights intensity is 9i. The other light's intensity will then be basically 4i. Now what is asked is nothing but what is max by min. We have seen the formula. Max is root I1 plus root I2 whole square. Min is root I1 minus root I2 whole square. This is what it is. One is for maxima, one is for minima sound. So this will be nothing but root of 9i plus root of 4i whole square, whole thing divided by root of 9i minus root of 4i whole square. I will get cancelled. Root, numerator, denominator, everything is same. Okay, so root 9 is 3, root 4 is 2, so 3 minus 2 whole square, and this is, 3 plus 2 whole square, and this is 3 minus 2 whole square, right? Root 9 is 3, root 4 is 2. 3 plus 2 is 5, 5 square is 25, and 3 minus 2 is 1, 1 square is 1. So 25 by 1 is the answer, which is D for IIT Delhi. It is D for IIT Delhi, right? Cool. Shall we go ahead? Shall we proceed ahead to the next one coming up on the screen? Right. Chalo. Let's move on. Let's move on. Two waves of intensity ratio 1:9 cross each other at a point. The resultant intensity is at a point when waves are incoherent is I1. When the waves are coherent is I2. When they are coherent, the phase difference is 60. What is the ratio of I1 by I2? Okay. And it is a numerical type of question which came this year in JEE Mains 2024. And the question is to find the value of x if I1 by I2 is 10 by x. Alright, let's understand the question slowly. Intensity of the ratio is 1:9. So let's say 1 is I, other will be 9i. Resultant intensity is when the waves are coherent and incoherent. So when they are incoherent, when they are basically incoherent, remember the intensities will just add. So it will be I plus 9i. So it will be basically 10 times of I. That is the value of I1 when they are incoherent. But when the waves are coherent with a phase difference, then the intensity is given by I1 plus I2, that means 9i, plus 2 root I1 I2, that means I 9i, into cos delta phi, that is cos 60 degree. So this will become I plus 9i, which is 10i, plus 2 into root I square is I, 9's root is 3, so 3i over here, cos 60 is half, 2 cancels, 3i plus 10i is basically 13i. Perfect. So now the final question says, what is the ratio I1 by I2? So I1 by I2 will be nothing but 10i divided by 13i. 10i divided by 13i, so it will be 10 by 13, so x will be basically 13. So x should be basically 13. That is the answer. This was actually asked. Many people did not know what to do when the sources are incoherent in 2024, and they suffered a lot. They would not have got the marks. How many of you got this in your shift? How many of you got this in your shift? Let me know. Very good. Cool. Let's go on. Let's go on now to waves on a string, special cases, basically standing waves, right? And then we'll go to beats and all the other things which are there in this particular chapter. Let's go quickly. Okay, so standing wave means when two or more waves you are having and they are going in the opposite direction, same frequency, same wavelength, same amplitude, so that their energies get cancelled and you will see that the energy gets trapped, and the resultant wave, the superimposed wave, is called as a stationary or a standing wave. So one wave A sin omega t minus kx going in the positive direction, another wave A sin omega t plus kx going in the negative direction. You add them, the resultant y1 plus y2, when you add them, you will get this combined equation. So 2a cos kx plus sine omega t, right? So this is what you should get. I don't know why this 2 is there over here. Not that 2. So this is the equation. Now, how does a standing wave look like? How does a standing wave look like? We'll come to that. So say for example, if I show a standing wave, you might see one particle not having any amplitude, another particle having small amplitude over here, another particle beside it having little bit more amplitude, another particle even more amplitude, then maybe again the amplitude begins to decrease like this, then maybe like this, then like this, and then no amplitude. Again this continues. So each particle has different amplitudes. Each particle has different amplitudes. You can draw an envelope covering both of them, right? You can draw an envelope covering the extremities. This is a standing wave, each particle having different amplitudes. These points over here, they are called as nodes because their amplitudes are the least, whereas this one over here is basically called as an antinode, and this much part is called as a lobe or a loop, and this length is lambda by 2 because you can see this is one wavelength, this is lambda by 2, this is lambda by 2. You will also see the amplitude of an antinode is basically 2a. It's basically 2a, whatever that a you wrote over here multiplied by 2a times, that 2a is the amplitude of the antinode. So all other particles, amplitudes are, you will see, less than or equal to 2a, or I would say more than or equal to 0. 0 is for node, 2a is for antinode. That is how it works, right? And those amplitudes, you can write it as a function. That function which is there, it will be basically 2a times, you can use sine or you can also use cos and then kx. So the amplitude at any location will be either a sine function or a cos function depending on how you are starting it, and 2a is the amplitude of the antinode. That is something which you should be aware of, right? Everybody till this point clear? Very good, very good, very good. Keep up the spirit, guys. When you will come live in NEET English, Sanjay, I'll be coming tomorrow or day after. Yeah, don't worry. Yeah. Right now your biology exams are going on, so that's why we are concentrating more on biology in NEET channel as well. You might have seen that, right? So this is the general equation. Either you can have sine or cos term for x, and same thing, sine or cos term for time. So a lot of people think that, you know, this is only the equation, nothing like that. You can have sine over here, cos over here, sine over here or cos over here, doesn't matter. One difference, compare it with normal waves. There you used to have kx plus or minus omega t. Here it is not plus minus. Sin kx is separate term, sin omega t is separate term. It's the product of two terms. sine, cos, cos, sine, whatever. Right? In traveling wave, it was kx plus minus omega t or omega t plus minus kx. So here you have product. That is the major difference in a standing or a stationary wave equation, right? All these things I have put it over here, right? These are all same. Now, all these things I have put up right over here. Now, whenever you want to produce standing waves, you need two waves going in the opposite directions. The best way to get it is via reflection. You send a wave, let it reflect, and it is coming back. So now you have two waves going in the opposite direction. Thus, you get a standing wave. Now, this standing wave again has three sub cases depending on how those reflections are happening. How those reflections are basically happening. Say for example, you take a string which is fixed at both the ends, which is basically fixed at both the ends, which is also similar to having a pipe which is closed on both sides, which is basically closed on both sides. You will see that at the fixed end, you will 100% get a node. You will get basically a node because fixed means it cannot move. Same thing over here also. In a pipe, you will see that at the closed end, you will get a node, and this node is a displacement node. Remember, in sound waves, particles pressure also changes and the particles also move back and forth. There is displacement equation, S is equal to Sm sine kx plus minus omega t, and pressure equation, Pm cos kx plus minus omega t. Remember that? There is pressure also, there is displacement also. Displacement node means the particles don't have the ability to move left and right so much because they are at the closed side of the pipe which you have taken, where you are creating that standing wave. But at that place, the pressure variations are maximum. Remember, anyways, pressure and displacement were not in sync. They had a phase difference anyways. So node is there of the displacement, which is antinode, which is antinode for the pressure, This is for organ pipes or standing waves produced in pipes at the ends. Similarly, you can also have a fixed side and a free side, which is identical to say that you have a pipe closed on one side, the wave that is produced will be having node at the fixed end and antinode at the free end, at the free end. So there is a node here and there is a antinode over here. Here also same thing happens. Node over here and antinode over here. Please remember, when I say antinode, it is again the displacement antinode, but it is also the node of pressure. Because this side is open, the molecules of the gas can go in and out easily, so their displacements are huge. So displacement wise they are antinode, but because they are open, the atmosphere will equalize, try to stabilize the pressure. So the pressure variations don't occur much. That's why the pressure variations are less. So that is the reason why there is a node of pressure over there. Yep. Definitely Uchuk Puchuk will be having mock test series. Yep. Cool. Till this point everything is clear. Another type of variation that you can have for creating standing waves is you have a string which is free on both sides. A string which is basically free on both sides, It is also as good as saying a pipe which is open on both sides, or basically just a simple open pipe. You will see antinodes will be generated on both the sides. Here also you will see antinodes which will be generated on both the sides. Okay, so this will have antinode. Same thing over here. At the ends you will be having antinodes. Needless to say, it is displacement antinodes. Why did I put all of them on the same slide? Because the formula for frequency etc. is the same for all of them, and the formula for these two is also the same. So till now what did I say? Till now I said that listen, whenever you send two waves in the opposite directions, you will encounter a standing wave, which is basically the energy which is trapped at a particular place. The equation also looks slightly different. There is no plus minus term. Here you have product of the sine and cos terms, or cos and cos terms. You have nodes, antinodes, you have lobes or loops which are being produced, right? Each lobe has a length of lambda by 2, and these standing waves can be obtained by reflection of sound or light or string waves, right? And you will see appropriate standing waves will be produced if you adjust the wavelength and the length of the string or the pipe appropriately. Then you will get very nice consistent standing waves. Or else you might sometimes see a node is here, then a node is here, then the node is there, antinode is distorted. So only at certain lengths or frequencies or wavelengths you will get these beautiful standing wave patterns, and it will make sure that the fixed end always has node and the free end always has antinode. Be it a pipe for sound standing waves or a string for standing waves of transverse waves on a string. Either ways. Okay, till this point it is clear. Now the frequency for which you get good sustained interference is when resonance occurs. So for resonance to occur, the frequency is given by Nv by 2L. Nv by 2L, V is the speed of sound, L is the length of the tube or the string. Whereas here, for the resonance to occur, the frequency will be odd times V by 2L. Also bear that in mind. Oh, sorry, not 2L, this is 4L. Odd times V by 4L. Bear this in mind, that this V by 4L is called as the fundamental frequency for an open pipe or a string which is, sorry, not open pipe, closed pipe at one side, or a string which is fixed on one side. Similarly, this just V by 2L part is also called as the fundamental frequency of the completely open pipe or completely closed pipe or string fixed at both sides or string which is free on both sides. All other frequencies you will see will be like whatever is the fundamental. Let's say I call the fundamental as F1. If I call the fundamental as F1, you will see all other frequencies will be like this: F1, then 2 times F1, then 3 times F1, then 4 times F1, like that. So you will have in general n times F1 when n is the harmonic number. So all the harmonics are present. All the multiples of the frequency are present. If fundamental is 10 Hz, then 10, 20, 30, 40, 50, everything is going to be present. But in case of fixed free or closed open kind of variation, then if the fundamental is taken as F1, then the frequencies which are present are F1, then you have 3F1 because this is odd, then you have 5F1, then you have 7 times F1, like that. Basically you have odd times of F1. So I can just say that only odd harmonics or multiples, harmonic means multiples, only odd harmonics are going to be present. Keep this in mind, right? Cool. You should also know how the nomenclature goes for overtone. So I'll just mention that over here. Say for example, fundamental frequency is 10 hertz, then some frequency is 20, then 30, then 70, then 80, then let's say it goes to 100, right? Then this is the fundamental, the lowest one is always called as the fundamental frequency. I can also call it as the first harmonic. 20 is 2 times of it, so this is the second harmonic. 30 is 3 times of it, so this is the third harmonic. 70 is 7 times of it, so 7th harmonic. Then you have 8th harmonic, then you have the 10th harmonic. You can see some of the harmonics are missing over here, okay? So accordingly you will give the numbers. Harmonic means multiple, 2 times, 3 times, 7 times, 8 times, 10 times. But overtone wise, it is slightly different. You just go serially, you just give serial number to it. Just like you give serial number 1, serial number 2, you list items 1, 2, 3, 4 like that. So this is the first item after the fundamental, so first overtone. This is the first overtone, keep this in mind. This is second overtone, this is the third. Don't even look at these numbers, just serially arrange them. Fourth overtone, this is the fifth overtone. That is how you arrange these numbers for overtone. Is this part clear, how this numbering goes for harmonics and for overtones, right? So all these things are given over here as well, right, mentioned for your reference. Let's solve some questions on this. The fundamental frequency of a closed pipe is equal to the first overtone frequency of an open organ pipe. Length of the open pipe is this, then the length of the closed pipe is how much. This came in JEE Mains 2024. Expect similar questions even in the second attempt. So let's start solving the question, but solve it separately for closed pipe and then for the open pipe. The fundamental frequency of a closed organ pipe. Fundamental frequency, when I say closed organ pipe, understand it is always considered closed on one side. A lot of people get confused. Sir, closed means closed on both sides or closed on one side? Closed means closed on one side. Because if you close it on both sides, then the sound won't come out only. Then it is not an organ. It is not a musical organ, because then how will the sound come out? Yeah, it can create standing waves, but it is of no application or no use for us. Keep this in mind. Okay. So if it is closed open, then the formula for frequency is odd times V by 4L. So the fundamental frequency will be V. Oops, sorry, I put V by 4F. V by 4L, and I will call the fundamental frequency is F1. Odd number will be 1. So V by 4 times of L1. This is what it is. Second time, for the first overtone frequency for an open organ pipe. Open organ pipe means like this. The general frequency formula is N times V by 2L. So the fundamental frequency will be 1 into V by 2 times of L2. These two frequencies are same as per the question. Right? They both are equal. It is clearly mentioned. So this F1 is equal to this F1, right? So V by 4L1 here and V by 2L2 over here will be equal. So doing that math, V by 2 times of length 1. Length of the open pipe is 60, length of the closed pipe. Length of the closed pipe is asked. V by, over here, this will be equal to V by 4 L2. L2 is for the open pipe. Open pipe, it is 60. So 60 comes over here. VV cancels, right? And what will be L1 equal to? What will be L1 equal to? It will be 4 into 60 divided by 2. So it will be, just check if it is coming out to be 120. Why am I getting 120? The length of the open pipe is 60, then the length of the closed pipe will be, have we done something wrong over here? Just check again. We'll see again once more. Or did they mention this for the closed pipe and we had been asked for the open pipe? I think I did a calculation mistake here. I should have put 4. I'm so sorry. This was V by 4 times of L1 is equal to V by 2 times of L2. And for the open pipe, it was 60. Yeah, my bad. Yeah, so now it is simple. Now it is simple. So L1 will be nothing but VV gets cancelled. VV gets cancelled. So L1 will be 2 into 60 divided by 4. So this will go 2 times. So this will become 30. So 30 means option number D. Yes. Oh, why have they given? Oh my God. This answer is different. That answer is different. Everything is different. So it should have been 30 centimeters, guys. It should have been 30 centimeters. The correct answer is 30. Okay. Clear? Everybody with me? Oh, but wait a minute. It was first overtone. I'm so sorry, guys. I'm so sorry. Let me do this again. It was not fundamental. This is fundamental only for the closed organ pipe. So this will be V by 4L. For this one, which is open on both sides, the frequency is NV by 2L. Because it is mentioned as first overtone means second harmonic, so N will be 2, so 2 times V by 2L, that will be the first overtone, which is the second harmonic. This is what it will be. So this is basically V by L, but this length is going to be slightly different. In fact, is it mentioned what is it for the open organ pipe? Yes, it is given to be 60. This is given to be 60. So V by 60 will be the frequency of the first overtone. But this frequency and this frequency are given to be equal. So that is why this should be equal to V by 4 times of this length, which is L1, V times of 4 times of length number 1. So VV gets cancelled and we will get length as 60 by 4, which is 15 centimeters, which is option number A, That is perfectly correct. So there was first overtone over there. So first overtone is second harmonic. First overtone will be second harmonic. Just think about it. That is the correct way of doing it. Okay. Shall we proceed ahead to the next one? Coming up on your screen? Here it is. Closed pipe 150 centimeters long gives 7 beats per second with an open pipe of 350 centimeters length. Both in the fundamental frequency. The speed of the sound is how much? Now, whenever these beats question comes, understand what you need to do. You might have a sound of certain frequency F1, another sound of slightly similar frequency F2. When you add these two sounds, what happens is you will get faint sound, loud sound, faint sound, loud sound, faint sound, loud sound, like this. You will see the amplitude keeps on changing. You will have loud and then faint, loud and then faint. This is what happens. The duration from one loud to the next loud or from one faint to the next faint is basically called as the beat period. This is called as the period of beat. And the beat frequency is 1 by the beat period. It ends up that the beat frequency is just the difference of the two frequencies which are interfering. It's just the pure difference of the beat frequencies which are just interfering with each other. That's all, nothing more. So you will hear alternating maximum and minimum sounds, which is basically the phenomena of beats. And this happens when the frequencies are very, very close to each other. Typically some 5 hertz, 10 hertz, 20 hertz difference, you can hear the beats. So this is basically your phenomena of beats. And that is exactly the question asked over here. Two pipes are there and their lengths and their, frequencies are close enough to each other. That's why you are getting 7 beats per second. Question is, what is the speed of the sound? Let's again try to take two separate situations, one for the closed organ pipe of 150 centimeters in length. So for the closed pipe, which is going to look like this, and that too in the fundamental mode, the fundamental frequency is V by 4 times of L. 4 times of L. So V, I don't know, 4 times of length. Length is 150 centimeters, that means 1.5 meters long. And this is basically your F1. Then a pipe which is basically open and of length this much, again in the fundamental mode. This is an open pipe. So the fundamental frequency of this particular pipe will be given by V by 2L. But this L is also different. So the length is how much? 350 centimeters, so 3.5 meters, which is V by basically 7. That is your F2. Now as per the question, it produces 7 beats per second. So if you take this frequency and subtract these two, you should basically get 7 beats per second. So actually this I can write it as V by 6. This is nothing but V by 6. So I just have to subtract these two. I'll get the beat frequency. I'll get the beat frequency as 7 hertz. So the beat frequency is nothing but F1 minus F2. This is given to be 7. So this 7 will be nothing but V by 6 minus V by 7. Correct? Everybody with me? So this will become nothing but 7V minus 6V divided by 6 into 7. So therefore, you will get V is equal to 7 multiplied by 6 multiplied by 7. 7 6 are 42 into 7. Do the maths. Answer should be 294. Answer should be 294. Yes, just check this out. Everybody understood how to solve this question? Solid for open pipe and closed pipe separately. Their fundamental frequencies you will get in terms of V. It is mentioned that the beat frequency is 7. That means the difference of the frequency is 7. So subtract this with this. When you subtract, the answer should be 7. Solving a simple equation, you will get the speed formula. Yes, Supriya, after the mains, we'll have advanced sessions, not before that. Okay, let's go to YDSC setup and their formulas. So in YDSC setup, main thing is you have a single source illuminating two slits which behave dependent on this. Hence, they become coherent. And at certain distance on the screen, you get alternating bright and dark fringes, which is the fringe pattern. From one bright to the next bright or dark to next dark, you call it as the fringe width. And this pattern, all right, you will see that the intensities are roughly same no matter how far you go, unless you are going really far, like till there. There obviously intensities will reduce, but in a decent range you will see the intensities are roughly same, and you get hundreds and thousands of fringes in this small region. So the angle of interest is also very, very small. So what are the typical formulas that you should remember? So let's have a look at that. Fringe width, angular fringe width. Okay, I'll just put it up over here only then. You go at any random point. You go at any random point which is at a distance of y, and let's say this distance is given to be capital D. This distance between the slits is given to be small d. Usually this is much larger than small d. Then the path difference at point P is given by d sine theta. Also, you will notice one more thing. If you drop a perpendicular over here, the base will be d, height will be y, and theta is basically this theta which I am referring to. This is the theta. Theta is also called as the angular position. You will also notice one more thing. Sine theta is roughly tan theta, which is roughly theta, which is roughly again y divided by d. Tan theta is height by base when theta is very, very small. Theta is basically small. This is the approximation that you can use over here. Another important formula is for fringe width. The fringe width is lambda d by small d from one bright to the next bright. In fact, I can put it on the next slide over here. Yeah, fringe width, right? So the fringe width is lambda capital D by D. You can also change the wavelength by immersing it in a medium. So wavelength inside a medium is wavelength in air by refractive index. That is a standard variation which you can get in problems. If you increase the distance or reduce the distance between the slits, the numerator or denominator will adjust so that beta will increase. Okay, you should keep that in mind. Also, you have angular fringe width formula over here. Angular fringe width formula, which is nothing but beta by d. If you do that, you will get it as lambda by small d. Beta by d, which is lambda by small d, that is angular fringe width formula. If you want to find the location of any maxima or minima, then for maxima's position, it is simply put n times of beta, or basically n times lambda d by d, which is basically n times of beta. But whenever you want to find the minima location, whenever you want to find the minima or dark regions location, then you need to be little bit careful. So it goes like this. It will be n minus half and it will be lambda d by d, or you can also write it as odd times beta by 2. So actually if you take it on the top, 2n minus 1 by 2, 2n minus 1 is odd number, 2 will come below. So odd multiples of beta by 2 is the location at which you will get different minimas, right? Shall we go ahead? Okay. Fine, let's go to some questions then. In YDSC setup, you are using bichromatic light, meaning there are light of two different wavelengths, 400 and 560. Distance between them is 0.1 and distance between the plane is 1 meter. The regions of complete darkness coincide when whose minima will coincide with whose minima? Where will they coincide? What is their minima number that will coincide is the question. So for minima, the formula that we use is basically odd number times beta by 2. So let's do it for both the cases. When wavelength is 400, when wavelength is 560. So the y minima in the first case will be odd number 1. Beta is, remember, lambda d by d. So this is odd number lambda d by small d, and this 2 is there as it is. So this will be odd number, wavelength is 400 into capital D by small d. Similarly for the other light, the y minima in the second case for this light will be another odd number 2. Lambda will be 560 capital D by small d. Because they have to coincide, it is clearly mentioned they are coinciding, hence these two should be equal. Hence the y coordinates, they will coincide when their y coordinates are equal. Okay, so this number is equal to this number means what and all will happen? Think about it. What and all will happen? You will have odd number 1 into 400. D and D will cancel, D and D will also cancel, will be odd number 2 will be there into 560 will be there. Is that right? Okay. Now just take the ratio odd number 1 by odd number 2. Odd number 1 by odd number 2, which is 56 by 40. Is that clear till this point? It is divisible by 8. So this will become basically 5. right? Everybody with me? And this will become basically 7. First odd number is 7, second odd number is 5. So now which minima coincides with which minima? Lot of you might think, sir, first wavelength 7th minima coincides with second wavelength's 5th minima. That is wrong. I'll tell you why. Because when I say odd number is 7, 1, 3, 5, 7. This 1 is actually the first minima. This 3 is actually the second minima. This 5 is actually the third minima. And 7 is actually the fourth minima. These are your odd numbers. And this is actual minima number. 1, 3, 5, 7. 1 is the first minima. There is the second minima. So, technically speaking, the correct answer for this problem will be 7 means fourth minima. So, fourth minima of the first wavelength, which is 400 nanometers, will coincide with odd number is 5. Odd number is 5 means third minima. Third minima of the other wavelength, which is 560 nanometers. This is the correct answer. Fourth minima with the third minima. Yes, this is the correct answer. Got it? Many students make a small mistake in figuring out which minima it is. If you make that mistake, then this is the problem for you. You should know how the numbering scheme goes. So when I gave you this particular formula right over here, that is the reason why I told odd number. That is why I told you odd number is a better way of remembering it rather than remembering n minus 1 by 2. Sometimes you forget whether it is n plus half, n minus half. It might be little bit confusing. That is why. Okay, this is another question. YDAC setup, 2 light sources, superimposing, part difference. The screen is 7 lambda by 4, ratio of the intensities of the fringe at this point with respect to the maximum intensity of the fringes. Okay, fine. At some point, the part difference is this much. That means delta x is 7 lambda by 4. Okay. Now, what I can do is 7 lambda by 4 is more than one wavelength. Anyways, one wavelength corresponds to 2 pi radian. This is like saying this is equivalent to, first of all, let me write equal to lambda plus what number will give you 7 lambda by 4? Think about it. Lambda plus what number will give you 7 lambda by 4? I think it should be 3 lambda by 4. It should be 3 lambda by 4. This wavelength is anyways one complete wave, which is 2 pi radian. This has no role to play in interference. Anyways, one wavelength is one revolution, one complete 2 pi radians. So the actual part difference will come because of 3 lambda by 4. That is effective part difference. That is basically effective part difference. So whenever part difference is more than lambda, try to take away all those lambdas before, try to take out all those lambdas before, so that the remaining part difference is less than lambda. It becomes easier to solve the problem because a lambda is always 2 pi radians. A lambda is always 2 pi radians. So that will help you simplify the question. Now the phase difference, which is 2 pi by wavelength into the path difference, which is 3 lambda by 4. 2 and 4 cancels, becomes 2. Lambda cancels, so it will become 3 pi by 2. That is 270 degrees. That's not the question. The question is about the intensity. All right. So the intensity at that point, I can use I1 plus I2 plus 2 root I1 I2 cos 3 pi by 2, right? So this will become 2I plus 2 into I cos of 3 pi by 2, which is cos 270. That is just going to be 0. So it is just going to be 2I. It is just going to be 2I. Is that right, everyone? It's just going to be 2I. Perfect. But you have to compare it with, the maximum intensity of the fringe. Now the max intensity that you will get will be for constructive interference, and that will be I plus 2 root II cos 0. This is for constructive interference. So this will be I plus 2I. Cos 0 is 1. It will become 4I. Now the question said the ratio you have to find, the ratio. So IP by I max will be 2I divided by 4I, which is basically half. So answer should be option A, and yes it is. Wow, what a question. What a question, right? Perfecto, perfecto. So these are the kind of questions that you can get, guys. Okay, be prepared for these kind of questions. Let's go to some more variations. Immersing the entire setup in the liquid. I just told you about it because the refractive index will change, wavelength will change, you will see the fringe width will change, but you will still see the central maxima at the center only. The position won't change of the center. Other fringes will come close by it. You will see the pattern will shrink because wavelength will go down, fringe width will go down. So there is a question on that also which was asked in 2022 and even this year. The fringe width is this much, entire arrangement is placed in liquid of this much refractive index. The fringe width will become how much? We know that lambda prime will be lambda by mu. Therefore, beta prime will be also beta by mu, since beta is proportional to lambda, because beta is lambda d by d, so it is proportional to it. So the same ratio should be obeyed here. If the old fringe width was 12, so the new fringe width will be 12 by 4 by 3. So 12 by 4 is 3. So 3 into 3, which will make it 9. So the answer should be B for IIT Bombay. Perfect. It is. It is. Cool. How to solve these questions? Very good. Very good. Then another kind of variation that you usually get is with regards to the slab insertion. You have placed a slab in between, and then what happens is the entire pattern only gets shifted. The pattern only moves either up or down. Okay. So in those cases, if the original maxima was here, central maxima, because you place a slab, you will see wherever you place the slab, exactly on that side, the pattern will also get shifted. The pattern will also get shifted. You will get the 0th maxima over here. This is the new 0th maxima, and this is the shift. This is the shift which is produced. As it is, it will be shifted out. So the formula for that particular pattern shift when you place a slab in front of one of the slits is given by, you will have thickness into mu minus 1, and then you have lambda capital D divided by small d. This is the formula. Please remember, if there are two slabs, then each slab will produce shifts in two different directions. So say for example, you have basically two different slabs, one slab here, one slab here. Then each slab will produce shift in two different directions. So the net shift which is produced, the net shift which will be produced will be modulus of shift 1 and shift 2, the difference, because each shift will try to shift it in other direction. This guy will shift it here, this guy will shift it here. Effectively, there might be no shift also, or some shift either this way or that way. So be careful, do not add it, it is subtracted. Okay, so when more slabs are present in both the in front of both the slits, this is for the net shift formula. So there are straight away questions on this, like this was asked in 2023, I believe. Now you can see there are two slabs which are present of two different refractive indices, and the question is the central maxima will shift by how many fringes? First of all, because there are two slabs and of same thickness, there will be a net shift which will be produced. There will be a net shift which will be produced, which is delta 1 minus delta 2 modulus. So delta 1 and delta 2, I can say it is thickness into mu minus 1. Mu is also different. Thickness is also different. No, thickness is same, 0.1 millimeters. So 0.1 into 10 to the power minus 3 mu is 1.55 minus 1 into lambda d by d minus thickness is again 0.1 into 10 to the power minus 3 into 1.51 minus 1 into lambda d by d. Okay, mod complete. Yes, you can take out few things common like 0.1 into 10 to the power minus 3 and lambda d by d. What will be remaining is 1.55 minus 1 is basically 0.55 minus 1.51 minus 1 is 0.51. This is what will be remaining. This is nothing but 10 to the power minus 4 into beta into 0.55 minus 0.51 is 0.04, I believe. And this is going to help me calculate how many fringes will it shift by. Because if it shifts by 5 fringes, then this shift will be 5 times beta. If it shifts by 4 fringes, it will be 4 times beta. If it shifts by n fringes, this should be n times beta. Beta will cancel. So n will be basically, I think there is, oh, my bad guys. I think I made a small mistake somewhere. So sorry. While giving you this formula, by mistake I put lambda over here. This lambda was not supposed to be there. This lambda was not supposed to be there. I'm just correcting it. Over here. So over here also, when we, yeah, over here also this d is not there. Sorry, this lambda is not there. Sorry. Let me just redo this. Okay, so this is going to be shift 1 minus shift 2. So this will be nothing but what I will say is thickness into mu 1 minus 1 into d by small d minus thickness into mu 2 minus 1 into capital D by small d, right? You can see thickness is common, d is common, small d is common, and here you have mu 1 minus 1 minus mu 2 minus 1, right? Now over here, to write it in terms of fringe width, here is what I will do. If the shift, net shift, I want to write it in terms of number of fringes, I'll write it as n times of beta. N is what I want to find. If it shifts by 4 fringes, 4 times beta. If it shifts by 5 fringes, 5 times beta. If it shifts by n fringes, so this will be n times of beta, right? And this beta is lambda capital D by small d. So this thickness d by small d, and this over here is mu 1 minus 1 minus mu 2 minus 1. Actually speaking, over here mu 1 minus 1 minus mu 2, this will become plus 1. You will see plus 1 and minus 1 will cancel, so it will be just mu 1 minus mu 2 over here. Now dd will cancel, all right? So you will have n is equal to thickness by lambda into mu 1 minus mu 2. Thickness by lambda into mu 1 minus mu 2. Mu 1 and mu 2 you know, 1.51 and 1.55, put it over here. Thickness also you know, lambda also you know. So thickness is nothing but how much? 0.1 millimeter. So 0.1 into 10 to the power minus 3. The difference of the refractive index is nothing but 0.04. This whole thing divided by lambda is 4000 Armstrong. So 4000 into 10 to the power minus 10, right? So just do it, you will get the answer close to 10. Yes, see if you are getting the answer as 10 over here. Cool guys, shall we go ahead to the next part? Okay, great. Right, I will start giving you the formulas of diffraction as well as polarization, and as well, because this is also a very important subtopic when we talk about waves. You will see most of the question papers will have polarization or diffraction as a question, solo question which will come. Diffraction is nothing but spreading of light, and when the light spreads, it also makes a fringe pattern on the screen, alternative maxima and minimas, and you need to know what is the angular location or the position of the minima or the maxima which is produced by the diffraction. Diffraction is basically spreading of light when it passes through a small hole or an aperture or a corner, whatever you say. So first of all, for maxima, what is the formula? Imagine you have a single slit. Remember, there are no two slits here. It's not YDSE where you have two slits producing interference. Even in a single slit, interference is obtained. And the manner in which you can think how interference happens even with a single slit is, you can think in a single slit, there are infinite sources which are there from one corner to the other, and each of these points acts like a source, secondary source, producing secondary wavefronts, and these wavefronts from these infinitely many sources from here to here, they interfere, producing an interference pattern on the screen. That is how you should look at it. So if you have a slit, single slit of width A, then if you want to see where the maxima will be, the formula will be A sine theta is odd times lambda by 2. The formulas are reversed. Whatever is there for YDSE is now exactly opposite for single slit. For maxima, there is odd lambda by 2. For minima, it is n lambda. A sine theta is basically n lambda. So A is the width, lambda is the wavelength, n is the number or the odd number you can also have, and theta is the location where you are going to find the maxima or minima. If you talk the width of the central maxima always extends from the first minima over here, and the first minima on this side. So this is the central maxima. This is basically your central maxima. This is your central maxima, zeroth maxima. This is your zeroth maxima. This is the width of the central maxima is 2 lambda capital D by small a. 2 lambda D by small a. That is the width of the central maxima which you should be aware of. There are straightforward questions on this, like in 2024 there was a question like a microwave of certain wavelength falls normally on a slit. The angular spread of the maxima of the diffraction obtained on a screen for the central maxima is how much degrees if the screen is 1.5 meters away. See, the width of the central maxima is this much. If you talk about the angular width, right, you just divide it by capital D. So it just becomes 2 lambda by A. 2 lambda by A is the angular width. So that's all you had to use over here. Delta theta was 2 lambda by A. 2 is 2. Wavelength is 2 centimeters. So 2 into 10 to the power minus 2. A, the slit width is basically how much? 4 centimeters. So this will just check 4 centimeters. So 4 into 10 to the power minus 2. Just check this out. The angular spread of the central maxima of the diffraction pattern obtained on the screen. Yes, lambda by A. Microwave wavelength normally on a slit of width 4 centimeters. Perfect. So 2 to the 4, this cancels. Delta theta is basically 1. Now, I'll tell you, the moment you get such a thing, you should be little bit careful, because delta theta being 1 doesn't make sense. So over here, this will be true only when the angles are very, very small. Otherwise, this won't be true. Otherwise, this particular relationship won't be true if the angles are not very small, because theta will be sine theta, which will be equal to tan theta. And that hint, we get it. This particular hint, we get it by looking at the options over here. 60 degree, 45 degree, 15 degree, 30 degree. None of these angles as such are very small. So what you need to do is actually find the location of the minima, first minima, and then find that theta value. So for minima, right, I would use just this formula, which is A sine theta is equal to n lambda. A sine theta is equal to n lambda. But for the first minima, n value will be 1. So sine theta will be lambda by A for the first minima. So sine theta 1 is lambda by A. Lambda is basically how much? 2. A is nothing but slit width, which is 4, right? 2 by 4 is basically half. So theta 1 will be 30 degrees. Theta 1 will be basically 30 degrees. So immediately you might mark option D as the answer, but that is not the answer. Be careful, because 0th maxima is here. 0th maxima is here. First minima is over here at an angle of 30 degrees. For the central maxima, you have to consider from first minima on this side and first minima on the other side. So the total angle which you will consider will be 60 degrees. That is the total width. Option A should be correct. Option A should be correct. Is that clear, my dear students? Very good. Very good. Be careful. Like whenever small angles are there, only then you can use sine theta is theta, and then you will be able to write A theta is n lambda. If theta is large, then do not do such things, okay? And that is the reason why I told you deliberately why the answer won't come by the formula 2 lambda by A. Many people by heart that formula 2 lambda by A for the angular width. It will not work every time. Is that clear? Everybody's head? Right, so the answer is 30 degrees. Moving on to more questions. Consider the diffraction pattern obtained from the sunlight using some small pinhole. If you increase the size of the hole, the size of the slit, what will happen to the diffraction pattern? The moment you increase the size of the hole, more light is collected. That means the intensity of the pattern should increase. Keep this in mind. And it so happens that whenever you increase the size of the aperture, the slit or that hole, the pattern will shrink. You will see the size will decrease. So answer is size decreases, intensity increases. How do I know that the size decreases? Look at even this formula. The sine of theta 1 is lambda by A. This is the place where I get the first minima. If the width increases, A increases, sine reduces, theta reduces. So the first minima is obtained closer. So the width, angular width will also reduce. So that is the reason why when you increase the diameter of that aperture, the size of the pattern decreases, but it will become more brighter, intense. That is why it is a very good question which was asked in 2021. Let's go to the final part, which is polarization, guys. So what happens if we take maxima both sides instead of minima? Kisant, then that will not be called as the central maxima. Please understand that. Whenever I say central maxima, right? Central maxima's width. This is how it has to be taken. This is your central maxima. This is where your 0th maxima comes. Your first minima comes here. First minima also comes here. Then your next maxima, first maxima comes over here. This is your first maxima. Then this is your first maxima. Again, after that, you will again get second minima. So when I say central maxima, it is from here till here. From here till here only. That is the meaning of central maxima. Is that absolutely clear? So always take from minima to minima, not from maxima to maxima. That is also a wrong understanding. Is that okay, Kisat? Cool. All right. Now, two things in polarization which you should know. Polarization is only there with transverse waves like light, waves on a string, ripples of water. But longitudinal waves like sound will not undergo polarization. In polarization, you will see that the physical quantity like electric field, or for a wave on a string, the displacement oscillates in a peculiar direction. That is the plane in which the particular wave is polarized, I would say. Now, usually the light which comes out of a bulb, right, or from sun, is not polarized, meaning the electric field may not oscillate in one peculiar direction. It might be having oscillations in all the directions as it is propagating. A small wavelength comes with this oscillation of electric field, then this, then this, then this, then this. All possibilities are there. So it is said to be not polarized or unpolarized light. When you take such unpolarized light, which comes from sun or a light bulb, you pass it through a polarizer, only a certain component of the electric field is passed in because of the electromagnetic properties. The remaining get completely cut out. So this unpolarized light becomes polarized in nature. And if the original intensity of the light was I0, the polarized light's intensity becomes I0 by 2. It becomes I0 by 2. Is that absolutely clear? Half the light goes away, only half the light passes by. Now, if this light, which has been now polarized, if this light, which has now been polarized, is passed through another polarizer whose plane of passing matches with the light's polarization plane. The light's electric field oscillates like this. You take a polarizer whose passing plane is exactly matching, then all the light will come out. Then all the light will come out as it is. All the light will come out as it is. There is going to be no change in the intensity. But if you take light which is polarized and you pass it through the polarizer such that the passing plane is exactly perpendicular, then you will get nothing over here. Then you will basically get nothing over here no matter what you do if it is polarized. But if you take some angle, certain angle, you take the polarizer, hold it at a certain angle, let's say I call it theta, then the light which comes out is only going to be polarized in that plane where the polarizer's plane exists. So component of the light passes out and you will get a polarized light in this particular fashion. And this intensity will be I cos square theta. Theta is the angle between the light's plane and the polarizer's plane, and the intensity of the light which comes out is I cos square theta. This is also called as Malu's law. This is also called as your Malu's law. Keep this in mind. Clear till this point? So if you have unpolarized light, then it becomes polarized. Intensity becomes half after passing through polarizer. Unpolarized light has vibrations in all the directions. Polarized light has vibrations only in one direction. If the polarizer is perpendicular, nothing will come out. If it is parallel or anti-parallel, everything will come out. If it is at an angle, I cos square theta, cosine square theta's intensity will come out of it. That is what you should know. Okay. Now, last thing which you should know is Brewster's law. If you again take unpolarized light and make it fall on some refractive medium, then part of it passes by, part of it gets reflected by. Then you will see that if in a particular situation where the angle of incidence theta b is such that the reflected light and the refracted light are perpendicular to each other. Reflected and refracted light are perpendicular to each other. Then you will see that the reflected light becomes polarized only for that particular angle. And when that happens, tan of that angle is the refractive index. This is called as the Brewster's law. So unpolarized light falls on a refractive medium such that reflected and refracted rays are perpendicular. Then the light which is reflected becomes polarized. That is called as Brewster's law. Okay, there is tan of that angle in it. Let's do some questions based out of it. If you take unpolarized light at an angle of 60 degree on a transparent medium, the reflected ray is completely polarized. The angle of refraction in the medium is how much? Let's try to understand it via a simple diagram. So, unpolarized light is incident at an angle of 60 degree on a transparent medium. So, it is incident like this at an angle of 60 degree on a transparent medium. It's coming like this. Part of it will get reflected. This will be also 60 degree. And we know that if it is completely polarized, then the refracted light should be perpendicular to this, should be perpendicular to the reflected light. If this is 60, naturally this angle will be 30 degree. If that is 30 and this is 90, naturally this angle will be 60 degree. If this is 60 because this is 90, naturally this angle will be 30 degree. This is your angle of refraction. So refracted angle is going to be 30 degree, which is option B. This is asked this year alone. JEE Mains 2024 question. Cool guys, everyone, shall we proceed ahead to the next one coming up on your screen? What does it say? N sheets which are polarizing in nature are arranged such that they make an angle 45 degree with the previous one. If you take unpolarized light and you are passing through this arrangement, the output intensity is I by 64. What is the value of N? Very good question. Let's try to think about it. First of all, you have taken unpolarized light. If you take unpolarized light, which is denoted by multiple arrows in all possible directions of intensity I, you pass it through a polarizer. What is the first thing that is going to happen? It will get polarized. It will definitely get polarized and the intensity will be I by 2. It will be basically I by 2. Now, what have you done? You have kept the next sheet such that it makes 45 degrees with the previous one. So you have another sheet over here which is making 45 degrees. So the next light will have an intensity of how much? I by 2 cos square 45, which is basically I by 2 into cos 45 is 1 by root 2. So it will be half again. So it will be I by 4. Oh, perfect. Then the next sheet will come. Again, it is at 45 degrees. So what will be the next intensity? This into cos square 45. So it will be I by 4 into cos square 45, which will make it I by 8. Then you place one more sheet over here. Then it will become nothing but I by 16. Then you place one more sheet. What will happen? It will become I by 32. And lastly, you place the last sheet. And finally, it becomes I by 64. I by 64. So, how many number of sheets have you used? 1, 2, 3, 4, 5, 6. So, answer should be 6. Option number A. This was JEE Mains 2023 question. Cool. That was your JEE Mains 2023 question. Beautiful question. Right? Cool. So, I think that's it from today's session. Remember, the crash course is still on. If you want to join the crash course, it's no longer at 12,000 rupees, 5,000, 4,000. No, it's come to 999 rupees, not even 1,000. It's 999 rupees. Make the best use of the crash course for study material, assignments, notes, lectures, one-shots, and support till JEE Advanced, including doubt support. Everything is there. The link is there in the description box below. And remember, Vedantu Learning Centers are also conducting special workshops. So if you want to get that physical attention, you want to meet the teachers, get some help, want some guidance, please visit the centers. We will be more than happy to guide and mentor you. Okay. So thank you very much. I hope you enjoyed the session. Smash the like button if you have forgotten to do so. And yeah, do not forget to subscribe the channel as well. Bye bye. Captain Shreyas signing off. Hasta la vista.